concerns about that? Okay, this is going to be so much fun. So here's the story. So we have a great show ahead today. We're really excited to have everybody here. And as soon as my slides show, we will get right into it. So this is the first ever DOE Office of Technology Transitions EnergyTech University Prize competition this year. And we are really pleased to be hosting the first Explore event. Super excited. I'm going to walk through what we're all about. We are here to really support and celebrate clean tech or energy tech innovations. I represent Clean Tech Open and Clean Tech Open Northeast, which is part of NECEC, and I'll tell you a little bit about that later. But I also want to make sure that you're all aware of what we're here for and what's happening. So the first thing we have is a video from Vanessa Chan, who is in charge of the Office of Technology Transitions. She is the head of technology commercialization at the Office of Technology Transitions, and we will hear from her. And then we will get into the run of show. I will introduce you to my colleagues and also to all of the judges, and we will get started. What I did want to also make sure you were aware of is that we have a really interesting show ahead during the time when the judges will be deliberating. So we will be hearing from 18 teams, all from the Northeast, really exciting. And then we will have little breaks in between groupings of the teams. But during the deliberation, while the judges are off trying to decide who should win and who the nominees will be for the specialty prizes, we will have some fun together. We're going to introduce you to Clean Tech Open, and we will hear from 3 of our alumni who have all been where many of you are today, and we are super excited to hear what you're working on that's going to make a difference in our environment and hopefully in the clean economy as well. And we will also have a chance to network with some folks. Now, this isn't just your average networking. So there are people in this meeting who could potentially be your colleagues, your partners. They could turn into advisors, potentially investors, perhaps a customer. So make sure to stick around. You never know whom you're going to meet in this next section. So I'm going to go ahead and play Vanessa's introduction. So here we go.
Welcome to the inaugural EnergyTech University Prize Competition. I'm Vanessa Chan, the Director of the Office of Technology Transitions, or OTT for short, and also the Chief Commercialization Officer of the Department of Energy. As a sponsoring office of EnergyTech Up, I can say that all of us here at OTT are humbled by the fact that we have seen a huge surge of enthusiasm from student teams, colleges and universities, incubators, and energy industry organizations. In fact, with 180 total applications from 113 schools, our inaugural cadre of teams represent 42 states, plus the District of Columbia and Puerto Rico. Not too shabby for our very first one. My thanks go out to my team at OTT, to the invaluable support we received from the National Renewable Energy Lab team, our partnering regional conveners, as well as the students themselves for their hard work. My vision for the goals and outcomes of this competition are: 1, to strengthen the energy innovation community across the US and territories; 2, to identify business opportunities for young entrepreneurs; and 3, to help lay a talent pipeline that will secure our energy future. We hope you all can take this opportunity to network and get to know the work going on in your region, because collaborators across schools catalyze future partnerships. Our mission at OTT is to help shepherd technologies through the research, development, demonstration, and deployment, or RD&D continuum, to ensure they are commercialized, and brought to the market. You're about to hear several inspiring, innovative ideas to do just that. This is an exciting time to be a budding entrepreneur because a clean energy transition is upon us. It will be revolutionary for our world, and we need all hands on deck to make it happen. Today, you are all on deck to play a role as you think and work towards that future. The students of today are the innovators, scientists, marketing specialists, policymakers, and entrepreneurs that we need. So with that, good luck, and may the best business plan win. But not to be too cheesy, you guys have all won by participating, because this is what we have to do to go hit our climate targets. Good luck.
Okay, thank you, Vanessa. It's great to have Vanessa leading this effort. So really appreciate all that the DOE and the Office of Technology Transitions are doing, as well as the National Renewable Energy Lab that is essentially running this program. So, oops, whoops, sorry about that. Okay, here we go. So now it is my distinct pleasure to introduce you to my team. So I am the Senior Director of Cleantech Open Northeast, which is part of NECEC. I'm going to introduce you in a moment to Tally Kane, our Program Manager, and Safia Elmi, you will see online. She is our Spring Coordinator and we are very pleased to have her working with us at this time. So this is our team. Now for the judges. So for many years, Cleantech Open Northeast has been running since 2005. We have had two of these three who have been working with us since the very beginning, John and John, and Greg has joined us a few years ago. They are our judging committee. So John, and Greg run our judging for all of the Cleantech Open Northeast, and they have been doing this for several years. The goal here is to make the judging fair and efficient. Hopefully you will all find that it is done that way, but you will get to see John, and Greg on the screen if you look for them. And then I'll just say John is working in a venture investment capacity. John Jadu. Greg Len is an attorney, an IP attorney with Troutman Pepper, and John Clavens is an attorney with Clavens Law Group, and the three of them are really our favorite trio for judging. I also want to introduce you to all of the judges that we've been able to put together here. So you'll see we have quite an interesting group. Some of them are alumni of Cleantech Open, and some are working in universities in different capacities. So Jinan Abunati is at the MIT Sandbox. Francesco Benedetti is running Osmoses. Linda Dickerson Hartsock is with Blackstone Launchpad at University of Syracuse, I believe. And Johnny Huang is president of Terratonics. Susan McKay with the University of Maine, who also happens to be an alum of Cleantech Open. Dan Nadav is CEO of EnviroPower, an alum of Cleantech Open. And Rob Parker is the director of SIF Capital, and he's working at, he does some teaching at NYU. April Salas is the manager of Climate Net Zero, and also is influential and involved with energy and climate technology at Dartmouth College. Chao Yen is our Cleantech Open National Grand Prize winner from 2021. And I neglected to say that, and his company is Princeton New Energy. I neglected to say that Francesco Benedetti of Osmoses and Johnny Huang of Terratonics are also Cleantech Open Northeast alumni winners. So I think without further ado, I will turn it over to Tally, and I will flip the slides when you tell me to.
Great, thank you, Beth. Hi, everyone, my name is Tally. I am the program manager at Cleantech Open Northeast. I have put together quite a nice run of show for us all. So we're going to start with 6 pitches in about 7 minutes, and then we'll have a 10-minute judge Q&A session, followed by a second 6 pitches. Actually, we had a last-minute conflict and one of our startups had to drop, and then another 10-minute judge Q&A, 6 pitches, 10-minute judge Q&A. And that's just how the system will go. So our judges are going to be reserving their strong, important questions for those blocks. So not every startup will receive a question. Not every judge will ask a question. If you in the audience have a question for a startup, please feel free to message that in the chat. We will be monitoring it. And if we have time, we will see if we can ask some of those. Just a few notes. The teams will be listening for my voice for the announcement that they will begin and then stop. They will have 5 minutes to present. The numbers for the teams, just so everyone's aware, are on the next page, which I will show in a second. During the breakout room later, after all of the pitches are done, you will have the chance to bounce around between rooms. So you'll have a really great opportunity to network with everyone that's here. And at 6:25, we will have our judges back in the main room and we will present our Northeast winner. All right, Beth, next slide. So for the rules, like I said, each team has 5 minutes to present. The judges will ask Q&A during the time block. And a quick note for our competing startups, please complete the DOE impact survey that we will send you after this event. It just helps give the DOE and us some feedback on how you felt everything went. A quick note for the audience, please keep your mic muted. We will mute you if something happens. And if something happens, technology-wise, there are numerous co-hosts, so someone will be up if I disappear or if we lose anyone. If you are a startup and you have technical difficulties, just let us know. We will do our best to accommodate to the best of our timing abilities and all of that. Next slide, please. So for the team order, just for everyone's reference, so you don't think I'm skipping anyone, there are no numbers 13 to 16. It was easier to add numbers at the bottom than juggle all of my teams so that they all lost their original number. The teams that have orange numbers have been moved, so that's a quick reference for my teams. If you see your entry title and it's at a different spot than you anticipated it should be, please let me know. It should not be. And I believe that is the last slide. Yep, that is the last slide. So without further ado, I will hand it back over to Beth for just a quick note on CleanTech Open.
Yeah, I just wanted to reiterate that that we hope that everybody who is participating in this competition considers applying to CleanTech Open. Our applications are open now. Our program is like a mini MBA with lots of connections and really will help to prepare you for your next steps with your venture. And you will hear from a few of our alumni, and they will explain a little bit more about what it's about and what their experiences were. So that's going to happen after all the pitches. So back to you, Tally, to call the startups.
Yes. Hold on one second. I want to make sure that we have the correct person. Okay. So our very first startup will be Edward Garcia is the registered name, but I'm not sure if that's the exact person given the presentation. Presentation number 1, a plug and play nuclear generator. Is that?
I'm here.
Okay, there you are. All right. You can begin when you're ready.
Okay, let me just share my screen. I can't share my screen. It's been disabled.
You can now. Yep.
Okay, all right. Okay, great. Can everyone see the screen?
Yes, you are all set.
Okay. All right. Hi, everyone. Thank you for having us here. We are Atom Industries. Atom Industries is a team that was formed at MIT. It is comprised of students from the Nuclear Science and Engineering Department, as well as the Technology and Policy Program and the Leaders of Governmental Operations Program. We are technically advised by Professor Jacopo Bongiorno, who's from the Nuclear Science and Engineering Department. And collectively as a team, we have identified a technology that can innovate how we go about industrial heat. Now, this technology is called the Long-Lasting Integrable Sustainable Energy Generator, or LISA for short. Now, LISA is designed to be factory fabricated, capable of baseload generation up to 20 megawatts thermal. It's capable of self-regulating and is modular in every sense of the word. Now, LISA is a type of nuclear reactor. It is a heat pipe cooled microreactor that is designed to be plug and play for both heat and or electricity generation, thus making it an ideal candidate for decarbonizing the industrial market. Now, the industrial heat market Despite the fact that it is one of the dirtiest sectors in our economy and responsible for a significant portion of our energy demand, it's a sector that does not really have a solution when it comes to meeting their ESG goals or decarbonizing their processes. And any existing alternative solutions are not necessarily well suited to act as a substitution. So when we look at the process heat portion of this sector, and we take a closer look at the technologies in this space, we notice that they tend to fall short on a couple of aspects. Now, one of the leading technologies in seeking to decarbonize this space is concentrated solar power. Now, while it is easily implemented and it is clean, it is not economically competitive with natural gas. And due to the land constraints at these facilities, it's not that easily scaled. However, our technology fits these 5 criteria almost perfectly. LISA is being designed from the bottom up to be economically competitive with natural gas. Since it is very energy dense and modular, it is easily scaled. Since it is designed to be plug and play with the existing infrastructure, it is easily implemented, and it is capable of clean baseload heat and electricity generation. But LISA is not just another small modular reactor. In fact, LISA is 10 to 100 times smaller than the leading SMRs, and this is important because it minimizes the land requirements and minimizes the construction costs required to site a unit at these facilities. LISA is also smaller than leading technologies, and this is important when you look at one of the leading technologies such as CSP being sited in one of these facilities. The gray square signifies the land area required to supply 20 megawatts thermal. Now, 20 megawatt of thermal energy is about the average size of an industrial boiler at these facilities, and they will require anywhere between 5 to 10 of these units. So land is of the utmost importance. And it's because of these constraints, as well as the requirements for this sector, that we have identified the natural gas boiler chemical steam market as the beachhead market. Now, the market size is about $8.4 billion, and we have picked this market because of its demand for heat less than 400 degrees Celsius, and it results in products that do not directly target the population. Additionally, this market is comprised of customers that are willing to explore innovative technologies because they are frustrated with the existing alternatives, and they are also facing external pressure from their stakeholders to make commitments to a low carbon transition, as well as to work towards their ESG goals. So when we look at this market much more closely, we realize that after we conduct a levelized cost analysis, that our technology not only provides a cleaner and safer source of energy, but it's also cheaper than the existing industrial heating technologies. And under a PPA contract, this technology would also protect the customers against any fluctuation in price that can arise from fuel price or carbon tax surges. Now, how do we actually get to the point where we sign a PPA with these customers? Well, our sales strategy is to identify target companies, which we have started doing, so that we can then sponsor industry conferences to make initial customer contact, so that we can then proceed forward to demonstrate our prototype and conduct lab visits, so we can then move forward with these customers to sign PPAs that are competitively priced while selling partial or whole equity. Now, in order to scale, we would then renew these PPAs and expand to additional facilities within the same company. So, and with this go-to-market strategy in this beachhead, we have identified a prosperous business future with an aggressive CO2 emission reduction. What you see here is the annual revenue versus percent market share captured. We estimate that each customer will give us about an annual revenue of $8.1 million per unit, and each customer will require about 5 to 10 units. Now, a go-to-market strategy and a sales strategy is great, but this is a nuclear technology. So we have also developed a licensing strategy in which we have identified a streamlined pathway within the existing regulatory frameworks that leverages policies that exist intended to foster the deployment of this advanced nuclear technology. And we're doing this so we can do so in a timely manner. Now, in order to measure our success, we have developed these milestones that we would need to meet. So generally, they are confirming the technical design specifications of our technology, followed by the safety bounding with respect to the regulatory requirements, so that we can then move forward and submit the NRC application to give us the licenses we need in order to construct our first demonstration unit and move forward with signing our first PPA. In order to do that, we would need to increase our human capital.
Thank you, Edward.
Okay, thank you.
Great presentation. And now we're going to have presentation number 2, Sunit Bindra with Agrisol AI. Agrisol AI, are you here? Agrisol AI, going once. Going twice. All right. we are going to move to presentation number 3, which is Wyatt Hendricks with small scale wave energy for off the grid needs.
Hi, everyone. How are you? Okay, so I'm just going to share my screen here. Okay. My partner ended up having something going on today, so he was originally supposed to be doing a lot of the talking. So we're going to see how this goes. Okay, so this is floating point absorber wave energy for kind of small scale and off the grid needs. I am from Maine, and there are a lot of coastal communities in Maine that actually are not connected to the overall power grid. And our team really wanted to kind of come up with something for these types of really rural and to our minds disadvantaged communities, instead of focusing on an idea that was just related to urban consumers or those on the power grid. So the technology being used is pretty simple. It's using like floating point absorbers. There are various different unique specifications for those different types, very scalable, very easily scalable. So this captures the power of a wave using a buoy, so pretty simple. General plan, so the plan suggests the usage of small scale FPAs to power kind of homes or the buildings or other items that are not connected to the power grid. And obviously with that, they need to be near a coastal area or near like a reservoir, like in the southern part of the US where they don't freeze over. Our target market is obviously individuals who own homes that are not on the grid and are near coastal areas. Currently, individuals are using something like solar. They use gas generators, and some individuals choose not to use electricity at all. One of the problems that we noticed and what kind of got us thinking about this was that a lot of these individuals, even if they're not using a large amount of electricity, still need to heat their homes. And currently that's being done with things like propane or things like burning wood. And, as we kind of try and move away from those people do need access to power power heat pump or something like that. And so we want to provide an option for those individuals. We've had, situations up here where there have been storms and stuff like that. And people who live in these sort of isolated areas, like on an island on the coast, are kind of trapped. They don't really, they're not connected to the power grid, and it becomes very concerning for them. So our idea is to sell these, flexible and scalable floating point absorber technologies to these types of communities. Wave power, when kind of compared to usage on like an overall power grid, gets outcompeted, really well by solar and wind. That stuff is just a lot cheaper in many areas, but in some areas, solar is not getting a great capacity factor because of the just not always getting the amount of sun that it would like to get. One of the problems that I've come up with when talking to people from the Maine coast is that they are a little bit concerned about things like installing wind turbines. They don't want to destroy the kind of natural beauty of the islands. With floating point absorbers and these types of wave technologies, they're pretty hidden, like a large part of it is under the water, and it's just a buoy that's sitting on the ocean. The Maine coast, for example, has 3 million lobster traps already, so we're very well equipped to handle putting buoys and stuff like that in the water. It's not going to create too much of an unsightly scene. So as far as competition in the industry, it's obviously going to be comparing to other technologies such as solar and wind. That's going to be a problem. The typical like 6 kilowatt solar system is something like 16,000. And if you need to go larger than that, obviously the costs increase pretty significantly. So obviously a big part of making this viable is trying to keep the costs comparable to solar. However, wave does have one advantage in that it is pretty consistent generation. It's always going day or night. Though there are seasonal differences and location differences in how much power is provided from waves, it's usually pretty consistent and can provide good base load generation. We really feel that this plan is going to help out disadvantaged individuals, and the focus on equity is pretty important to us. We think it'll help people who really need to move off of fossil fuels, but maybe but for whom solar maybe isn't the best option. So I'm close to 5 minutes, so I'm all done, but thank you guys very much for listening and have a good day.
Thank you very much, Wyatt. Great presentation. We're going to head into presentation number 4, Noah Daniel with DeHelios, a solar cooker competitive with firewood.
So we are the Dartmouth Humanitarian Engineers, and we have developed a solar cooker cost competitive with firewood for use in Ugandan schools. So the problem is that 800 million people in sub-Saharan Africa do not have access to clean cooking fuels. And this leads to a variety of problems, including smoke-induced disease, deforestation, greenhouse gas emissions, and an increasing price of firewood. So there's an opportunity here within schools for decarbonization, because 90% of schools use firewood to cook with and heat water, because a lot of the staple foods necessitate boiling large quantities of water for maize porridge and beans. So there's been a failure of alternatives like electric cooking, liquid propane gas, and solar ovens, because they're unreliable in changing environmental conditions and they're expensive. So our proposition is a scalable solar-powered thermal system that can preheat water to reduce cafeteria firewood consumption by 50 to 75% in schools. This is a diagram of our system. So the basic principle of our system is having 2 tanks that alternate function daily. So on the left here, we have the tank that is being heated for the next day. It's connected to the pump, which is powered through a PV panel, to a panel array of glazed plate panels to heat the water. And while the tank on the right was preheated the previous day and is being used for cooking today. And then the subsequent day, the tanks would switch roles and the tank on the right would be heated, whereas the tank on the left would be used for cooking. The reason why we chose glazed plate panels is because they're proven, efficient, and inexpensive. And here's an image of our prototype system in Hanover, New Hampshire. The ambient temperature was 10 degrees Fahrenheit on this day, and we managed to raise the temperature of the water to 140 degrees Fahrenheit. So we know this technology works.
Awesome. Another exciting aspect is we are working with a secondary school actually in Uganda. So we've had access to interviewing their cooks and acquiring real life data. We found if this system is implemented as we calculated, there could be a 15-year NPV with an R of 10% of $16,800, the payback period less than 2 years, which is really exciting because the school spends over $4,000 a year on firewood just to preheat and boil water. We also found we could dramatically reduce the smoke exposure and the deleterious effects on health because the water is preheated, so less time is spent in the kitchen. In addition, this could also increase productivity and have a vast environmental impact by displacing firewood, with 30 less tons of CO2 emitted annually and approximately 1,000 square meters of forest saved every year from deforestation. Next. So the question is, if this is such a great idea and solution, why hasn't it been done before? And we think there are a few reasons. One, as you see with solar stoves or some PV mini grids, there's been focus on complete decarbonization, which is less practical and more expensive. And in order to work with these institutions, you need multiple stakeholders as they lack a lot of the immediate capital and sometimes the experience to devise these systems. And key components such as solar panels for the pump were too costly, but we've seen PV panels price decrease dramatically recently. There's a lack of a turnkey solution in which the system can be sold with all the pieces necessary to these schools. Next. And so the initial target market would likely be educational institutions in Uganda. It's a really vast market with over 25,000 schools in Uganda that cook with firewood. And as over half the population is school age, there are over 20 million enrolled students. And its advantage to work in Uganda is we already have established contacts. In addition to Beacon of Hope Secondary School, we have contacts at Uganda Christian University who are interested in installing a system of their own. Next. So the customer economic analysis, we plan for direct sale to school, although many of these schools lack the capital required for an upfront purchase. We can do an installment plan. So based on the annual firewood savings, for example, for Beacon of Hope, this could be almost $3,000 a year. There could be no net change in annual cooking costs if the payment plan is based off of the firewood savings displaced by the system. And even with a 10% capital cost being allocated for profit, we can still achieve a payback period within our target range of 2 or 3 years. Next. So our overall business plan is, first, we want to develop an effective prototype in Uganda, a pilot system, which is exciting as we're actually planning to go to Uganda Christian University, where we have partners there who help us get the materials necessary to do this. We then want to install a second round to other institutions, such as Beacon of Hope, and connect with other regional schools in Uganda, and then hopefully develop a scalable, sustainable business model to expand throughout Uganda, but also other countries in sub-Saharan Africa, as there are 800 million people there who cook with firewood as well. Thank you.
Thank you very much, Noah and Anna. Great presentation. Up next, we have presentation number 5, James Donegan of Electricity Production with Negative Emissions.
We're here, just getting screen share set up.
Yep, no worries. All right, ready when you are. We can see your screen.
Awesome. So this pitch is about a company, Mantle, that is setting out to achieve something that sounds unquestionably too good to be true. And that is produce green baseload electricity with negative CO2 emissions. Now that may seem unnecessary, but if you look at projections from the UN related to 1.5 degrees C global warming scenarios, they require up to 5 to 15 gigatons per year of negative emissions of CO2. And that sounds like a really big number, but when you put it in context, it can be even worse. 15 gigatons a year is equivalent to the combined emissions today of China and the United States, the 2 largest emitters. Emissions that we not only need to eliminate, but actively remove from the atmosphere. Now, one way you can do this is by pairing 2 clean energy technologies, biomass power plants with carbon capture and storage, what we call BECCS. But if you look at why they haven't been paired successfully in the past, it's primarily because existing carbon capture technologies have just been too expensive. They place too much of an economic burden on the power plant's operations. And people have tried a lot of different carbon capture materials, liquids, solids, operating at high temperatures, operating at low temperatures. But despite all these efforts, until now, no one's exploited this combination of being a liquid phase material and operating at high temperatures. And this is where we come into this story, having developed a novel patented solution with molten borate salts. Now, why would you want to operate at high temperatures and be in the liquid phase? High temperature operations reduce the energy penalty associated with carbon capture, and liquid phase materials are immune to the cyclic capacity losses that solids experience at these temperatures. These 2 benefits, when paired together, can reduce the cost of carbon capture by up to 40% compared to existing solutions.
So there are a number of different opportunities to use our technology. The technology solution space that excites us the most is called bioenergy with CCS, BECCS. The reason, as Sean explained, is you can do carbon removal, which is different from carbon abatement and is higher value because there are fewer technologies that can do it. We're particularly interested in going after retired US bioenergy plants and converting them into BECCS facilities using our technology. We've identified 10 to 20 that exist and could profitably be converted to remove over 1 million tons of CO2 every year. Beyond that, there are 330 existing bioenergy plants that are typically unprofitable and soon to come off PPA. Converting those could extend to 50 million tons per year. And the US has the potential to burn waste residue from a large number of agricultural and forestry waste products and remove over 300 million tons of CO2 per year from the atmosphere. Extending this globally, we think we can do at least 2 gigatons of CO2 removal just using waste biomass from these processes. To bring this to life, we've identified an example project in Lufkin, Texas. This is a power plant that was built off PPA and only ran for a few years because prices of electricity plummeted in Texas. It transacted in 2015 for $5 million, and we've analyzed this plant and expect that we could spend 30 million upfront to remove 200,000 tons of CO2 per year. In combination with existing credits and the carbon removal credit market, electricity market, this this achieves a very attractive return. But we're a long way from this. Our technology has been proven in the lab and demonstrated at the gram scale. We're looking to build a flow loop and demonstrate the technology under flow at the kilogram scale, while simultaneously developing the project for the first demonstration plant. We're in a slow moving industry, and we need to front load a lot of that work to get the demonstrate plant running and move quickly. That demonstration plant would capture CO2 and demonstrate the performance at the ton scale, at which point we'll be ready to scale with various partners to make our vision a reality of removing gigatons of CO2 from the atmosphere at a low cost. We've talked with a number of partners. That I mentioned, this is a complicated space and we can't do this alone. We see Mantle as orchestrating this vision and bringing about multiple partners together to realize negative emissions. These include the actual buyers of carbon removal credits. Companies like Microsoft and Stripe are leading in this space. The actual transport and storage of CO2 once it's captured, Carbon Verde, Chevron, the oil and gas majors. Plant operators, biomass suppliers, EPCs and designers, and also the project sponsors, the equity sponsors, the actual financiers of these projects. And this is where it's particularly difficult, as we have to try and find sources of capital that are willing to take risk on our technology. And this is somewhere where the DOE and other early project financiers can step in. And with that,
Wonderful.
thank you very much for your listening. And you're right on time, Tally. Thank you.
Great job. Great presentation, Sean and Cameron. Moving forward for our last presentation of the first block, we have presenter number 6, Jared Entwistle with electromechanical storage in rural transportation.
Hello,
All right, you're all
everyone.
set.
Hello, my name is Riley Linkle. I'm here with my colleague Jared Entwistle, and we'll be speaking today on the potential future uses of electromechanical batteries in school buses. The research for this new technology comes from the Lawrence Livermore National Laboratory in Livermore, California. And while these batteries are in early development, they hold a lot of potential for future electric vehicles. The electromechanical batteries are a system of 2 carbon fiber flywheels and a vacuum sealed chamber used to store kinetic energy in electric vehicles. These flywheels spin in opposite directions to counteract the torque that each produce. These batteries will be in competition with the current electrochemical batteries that are on the market right now. And electrochemical batteries use a chemical process to store energy that can be transferred back into mechanical energy later on. The electromechanical batteries utilizes magnetic bearings and the vacuum sealed chamber to create a near frictionless environment in which this environment will produce a predicted 95% or better efficiency in comparison to the current 60 to 75% efficiency rate of electrochemical batteries. It's projected that the electromechanical batteries can hold 3 to 4 times the amount of electricity per kilogram, resulting in a lighter and more efficient vehicle. The Maine Climate Council is looking to reduce the number of vehicle miles traveled per year, in which an electric bus network would provide a sustainable solution. The electromechanical battery gives opportunity to an electric bus network to form and thrive by providing buses with reliable power in all weather conditions. If the network was to be converted now, the cold, wet winter temperatures would heavily reduce the lifespan of electrochemical batteries, such that it would not be feasible to run during winter months. Go ahead, Jared.
I'm sorry, I didn't realize I was still muted. Our business plan focuses on the production of battery electric buses, leveraging these batteries developed by Lawrence Livermore. Because these batteries are produced using lower cost materials and are almost 4 times more energy dense than traditional chemical batteries, we estimate that we can produce lower cost buses with similar capabilities to traditional battery electric buses. Initially, we will focus on 2 tiers of production. Our high range model will have an estimated cost of goods sold of around $200,000 per unit and sell at a market competitive rate of $350,000, but it would compete with the range of diesel buses. Our EV market comparable model will have a cost of goods sold of around $150,000 and sell for $260,000, a discount of about $90,000 when compared to traditional battery electric buses. We estimate a 2 to 5 year development stage at an average cost of $1 million a year. This stage will seek to utilize partnerships with Lawrence Livermore and New England Bus Rebuilders, a diesel to electric conversion facility based in Boston or Massachusetts. A successful partnership with NERB would lead to expanding our product catalog to provide bus chassis as well as the full bus system. After the development stage, we estimate needing an additional $15 million for facility purchase and build out and startup operating capital. We intend to obtain funds through federal and state grants, loans, and investment rounds. Our business model focuses on the Northeast due to the absence of competition and high federal and state incentives. Currently, more than half of electric buses are produced and sold in the West Coast, and those that aren't are typically found in the southern states. This leaves customers in the Northeast with few realistic options. We seek to solve that issue. With electromechanical batteries, cold temperatures have fewer effects on standby energy retention, making them more realistic for the winters experienced here. This also makes them the ideal battery for maximizing solar energy benefits. Additionally, power outages are common in the Northeast. We intend to design the buses with backward compatibility, so that the energy can be supplied wherever and whenever it is needed the most. Thank you for your time and consideration.
Thank you, Jared and Riley. We are at our first judge Q&A session. So our judges, do you have questions for our first 6 pitches or 5 pitches, I guess, since we missed one, either for plug and play nuclear energy generator, a small scale wave energy for the off-grid needs, for off-the-grid needs, DH Elios, a solar cooker competitive with firewood, electricity production with negative emissions, and electromechanical storage in rural transportation. You can feel free to raise your hand and I can call on you just to make it a little bit easier.
My camera does work. Okay, great. May I go?
Yes.
So here's a question. I think that you're on the dot when it comes to the problem, the challenge for decarbonizing heavy industry. It's a well-known and growing problem, big challenge. But I haven't heard you mentioning hydrogen, which seems to be now the growing in favor solution. I wonder if you actually can touch on that, because ignoring hydrogen and the promise of hydrogen to decarbonize heavy industry is there. And I'm sure every investor that you will approach would probably look into something else.
Can you remind me which team you're asking?
The first one.
Edward Garcia, are you still with us?
Yeah, I figured that may have been.
Play nuclear energy generator. Or,
yes. Yes. So I agree that people are looking into hydrogen for decarbonizing, the higher temperatures. But we are primarily looking at the portion of the market that can be met with less than 500 degrees Celsius. Now the thing with hydrogen is that we have thought about it, that it is a competitor in the space, but really there's issues with hydrogen integration with the existing infrastructure, and that if you sort of swap out what we have and you just put in hydrogen, you have to start worrying about the effects of hydrogen on the pipes, mostly via hydrogen embrittlement. So that can actually cause a feedback loop with the steel industry, and actually, there will be an increase in steel production to make the appropriate pipelines that are adequate for hydrogen. For hydrogen infrastructure, but mostly hydrogen makes sense for the higher temperature ranges, above 1,000 degrees Celsius, since you can really just burn that at whatever temperature you need. So we're looking at the process heat, which is less than 500.
It was not criticism by any stretch. I thought your presentation was really interesting and very well maintained. It was just a comment, but that's an industry, by the way, that I know really well. We do several projects there in the waste heat recovery. If you're interested in that path for that, I'll be considered, again, the interest there to mentor you.
Yeah, thank you.
Sure.
Awesome. We'll head over to John Clavins. I believe your hand is up first.
Yeah, for the nuclear technology company, maybe others caught it, but I didn't really catch what exactly the technology is besides small scale nuclear, and what's the status of the development of the technology.
Yeah, so besides it being very small, it is actually dry cooled. So it doesn't use water as traditional nuclear uses for the coolant. It is cooled using a bunch of heat pipes. So about on the order of 10,000 heat pipes to transfer the heat. This has been proven at a smaller scale. The most famous example is the NASA's Crusty heat pipe reactor. So this has been proven at a smaller scale. So really the biggest the biggest things that distinguishes our technology from existing SMRs is that it utilizes low enriched uranium fuel, and it's cooled with these heat pipes. So you can think of this as a solid state reactor that doesn't have to worry about a loss of coolant accident, and it doesn't have to worry about any pressurization problems, which is what's considered for light water based small modular reactors.
All right, April.
Thank you. And wonderful presentations by all. I had a couple of questions, but I'll stick to the first one, which is from the last company presenting on electrical, mechanical storage and rural transportation. And my question, I heard some numbers being thrown around about cost comparability and sort of comparing it to the incumbent technology of non sort of EV models. And I was wondering if you could just restate what those were, and as well as any thoughts on sort of codependencies around supporting infrastructure charging, which is also a big sort of concern in the New England region. Thank you.
Yes, thank you. So just restated, and I'll say this as well, I stumbled over the word electromechanical many times, so you're not the only one. So the cost of goods sold for the high range model would be about 200,000 and selling for around 350,000. It's a little hard to tell right now what the cost of goods sold would be, simply because they don't have numbers on what the batteries would cost at this time. So throughout this competition, that's something that we'd like to get in touch with Lawrence Livermore to nail that down a little bit more firm. And then in terms of grid capability, our intention is to start out in Maine because they have, it'd be kind of like a proving grounds. And they have a lot of incentives at this time to get charging stations up and running, especially for schools. And so we're trying to, I guess, capitalize on that interest by the state.
Great. And just one clarification for the cost of goods sold and the sales price for the high range. Thank you for restating those. I just wanted to, I thought you'd mentioned what sort of a comparable non-EV model was. So like, what is it displacing? And is it cost competitive with sort of the incumbent school bus, for example?
Sure, yeah. So current EV buses, they sell for somewhere between 350 to 400,000. And they have a range somewhere around 150 miles. And so our comparable EV model, the lower end, we're estimating that cost would be about 150,000, and we would sell it for 250,000 or 260,000. Does that
There's
answer
another
your question?
Oh, go ahead,
Sorry.
April.
It does. Thank you so much.
There's another question in the chat for you, Jared, about the heating. So the challenge with electric vehicles is the power needs of heating. Given that you're targeting Maine, how is the range impacted by the outside temperature?
It does definitely decrease it quite a bit. Most heaters, I think, rely on heat pumps in the bus themselves. I think the advantage here is that because we can pack so much more energy into these buses, you might not have an issue. I mean, in the US, the average mileage traveled by a single school bus in a day is around 60 miles, 60 to 70 miles. So if you're losing half of your range just to keep the seats warm, then you're still going to be fine for an entire day.
Wonderful. Do any of the other judges have any other questions for any of our first 5 teams? Does anyone in the audience have any questions? Oh, here we do have one more question. Could each of the teams tell us what phase they are on product development, if you have a concept, a prototype, etc.? So I think that's a helpful question. We can run through it really quickly. We'll start with Edward, if you want to give a quick update.
Yeah, so we're actually in the process of beginning the simulations of what's going on within the core, just to make sure, that our design assumptions are correct. So that's where we're at in terms of our product.
Awesome. And Wyatt?
Yep, a lot of this similar technology exists for larger scale. So basically the development still needed is to apply this in a smaller scale to the small communities we're targeting.
Awesome. Noah and
We have a prototype.
Anna?
Oh, sorry. We have a prototype we have created and been getting data from here in the US. And then this summer, we're working with Uganda Christian University to install a large scale or full scale one there.
James? I think it was a different presenter.
That's Untitled Chapter.
Yeah, okay.
We're at TRL 3 to 4. We have a lab demonstration project, process simulations for the real thing. Looking to go to 5 to 6 with our next step.
And Jared and Riley?
We're in the concept phase.
All right. Any other questions, judges? All right. Great job to our first block. Congratulations on finishing up. You are, we're happy to have you for the entire rest of our session. We want you to hear the other presentations as well as get to do networking. So as we move forward into our second block, quick reminders for our audience, please keep yourself muted. And for a reminder for our startups that might be just joining us, I know we have a few coming in and out of exams and classes and things like that. So startups that are joining us, you will have 5 minutes to present. You can share your screen. The judges will ask questions in a 10-minute block after 6 presentations have finished. If any of our startups have technical difficulties, we can move blocks. We can have you go at the end, things like that. Do any of the startups for the second block have any questions or concerns before we get started? Okay, so let me get up my team list and we are going to start with presentation number 7, Cody Plante, Fair Fruit and Energy Exchange.
Great, that's us. Thanks so much. Let's get our screen share set up.
We can see your screen. You are all set.
Excellent.
Fantastic. Hello, everyone. My name is Dylan, and this is Cody. We'll be presenting on Village Industrial Power and Fair Fruit Exchange, a combined model for decentralized production and market linkage of dried fruits. Let's jump right into it. There you go. Post-harvest loss is a significant problem for small-scale producers, especially in the developing world. They face low fragment prices and strict fruit selection standards by brokers due to market saturation and seasonal availability. We've developed an innovative commercialization model to help rural farmers access higher paying markets for their crops and finance renewable energy technology solutions for crop processing. And Cody's going to break down that technology now.
Yeah, so our technology is a biomass fueled combined heat and power plant, and our chosen configuration provides 10 kilowatts of electricity and 40 kilowatts of thermal energy The engine is 2 to 3 times more efficient than a traditional steam engine, boasting the same longevity, and it recycles the water, making it ideal for rural communities. And when thinking about our thermal and electrical producing design, we began to look at smallholder farming in Africa and India. We found that 30 million smallholder farmers in these areas lack access to reliable heat and power to process, preserve, and most importantly, profit from their crops. In some cases, post-harvest losses reach 40%. To aid in this area, we can use our product to dry the farmers' crops and maintain their freshness. Using our platform, rural farmers are able to achieve 3 to 5 times value addition for their crops and eliminate post-harvest losses. Drying on farm reduces the fresh fruit weight by up to 90%, similarly reducing the subsequent transportation expenses and CO2 emissions. Fair Fruit Exchange provides a competitive advantage compared to current options available to small-scale producers to market their crops. Farmers achieve improved economic outcomes and improved reliability in their ability to market their crops, and it has improved environmental impact. Our customers include smallholder farmers in the developing world with at least 250 fruit-bearing trees that face issues with post-harvest loss. Our customers benefit from access to higher-paying markets, which allows the energy technology to be scaled from a financing perspective. We've developed our system to ensure fruit processing is standardized for compliance to the US as the end market, having the largest market share of processed fruit products in the world. For just the crop processing technology in Kenya, we've conservatively calculated a serviceable obtainable market of $94 million based on the scope of post-harvest loss for smallholder farmers only and just the mango crop. In terms of providing crop processing technologies to farmers, we earn a gross margin of about 16% on the energy generation technology and a gross margin of about 40% on the crop drying technology. And each core unit of energy generation can support 2 of these crop dryers. Providing market linkage for dried mango, we earn a gross margin of about 45%, assuming an average selling price of $16,000 per metric ton of dried fruit. Each installation has a total production capacity of up to 18 metric tons when operating at 75% capacity, 20 running days per month, 12 months per year. The long-term success of our model relies upon engaging asset financing partners and lenders, ensuring compliance with FDA food safety standards, maintaining regulatory approval from foreign authorities, and maintaining relationships and quality standards with food wholesalers and consumers. Assuming a January 2023 market entry, we're anticipating sales of 5 whole products in year 1 at the beginning of the 2023-2024 mango season. We also anticipate 7 metric tons of dried fruit production in year 1, estimating a 50% production capacity at 20 running days per month. As you can see from our year 1 cash balance curve, we have a healthy allowance for margin of error and implementation plan. Year 2, we anticipate sales of 20 whole products based around a typical mango season. We also anticipate 144 metric tons of dried mango production. We've modeled year 1 installations at 75% capacity for 20 running days per month, given the learning curve for production. Year 3, we anticipate sales of 100 whole products and moving into year-round dried fruit production. Finally, this shows our cash balance curve for year 2 and year 3. And with that, we're happy to take any questions. Or we'll stop share.
Great. Thank you both. Great presentation. Moving on to our next team, number 8. Bharath Kumar Bhaskaran, gas form, circularizing formic acid production.
Hello, can everyone hear us?
Yes.
Great. So, hello everyone, we're gas form. So our goal is to circularize formic acid production in agriculture. I'm Bharath.
And I'm Cindy. Before we jump into our
Excuse me. Okay.
Before we jump into our technology, we'd like to talk to you about anaerobic digesters. These are programs funded by the EPA that recycle waste in farms, such as manure, into biogas, which is a combination of methane and carbon dioxide. Biomass is broken down into microbes, and biogas can be sold or combusted to generate electricity and reduces emissions from fossil fuels. However, anaerobic digesters alone frequently fail due to process economics. What we propose is to add an additional carbon dioxide electrolyzer that reduces the carbon dioxide produced during biogas combustion into producing a diverse set of valuable products each with different levels of profitability.
So when we're choosing our initial product, what we want to consider is that we want to beat our base electricity costs and the base cost of carbon capture. And it's essentially what this plot is showing. That diagonal line captures that cost so that you get 4 quadrants of products. The ideal ones are easy to produce using current electrolyzer technology and have a high margin over the base electricity. What makes formic acid such a great initial beachhead market is that the market size itself is fairly small, enabling us to compete with larger scale synthesis efforts, but it's still steadily growing. Additionally, the uses of formic acid are primarily agricultural. So it gets used in animal feed and salad as an antimicrobial agent and in leather tanning for dyeing purposes. And what this means is that because we have this linkage between the anaerobic digestion on farms and formic acid use on farms, we can satisfy this demand through on-site electrosynthesis.
What we propose is to combine anaerobic digestion with carbon dioxide reduction into producing formic acid. And we propose this to establish a new agricultural cycle. We start with our farm animals that produce manure that are fed into anaerobic digesters to produce biogas. The biogas is then funneled into a biogas fuel generator, which produces carbon dioxide and electricity. The carbon dioxide and electricity is then sent to an electrolyzer to produce formic acid, a product of choice. The formic acid can be used for things such as leather tanning or antimicrobial feedstock treatment, and these can be then sent back to the farm to complete our cycle. Furthermore, as my partner will talk about shortly, we have determined that we will also generate surplus electricity that can be sent back to the farms or sold to the grid for additional profit. What I boxed here is gas form, and that is what we propose to use with our technique.
So we began crunching some numbers to figure out our base operation scale and profitability. So an average anaerobic digester produces around 6,000 cubic meters of biogas. And from that, we anticipate using most of that biogas for formic acid production, roughly 90%. And that equates to around 2,900 kilograms of formic acid produced per day for the farm. And that in turn displaces CO2 just through the capture of CO2 capture from the electrolyzer technology. And we haven't even begun to account here for the transportation savings of otherwise shipping the formic acid to the farm. When we're looking at it on a per kilogram basis, or in terms of our initial installation and operation, our base CapEx is for the electrolyzer itself with some operation and maintenance costs for that. But then our recurring cost is the biogas that we have to purchase from the farm. But what's great is that through this model, we're able to sell our formic acid at a price that's roughly 10 cents below the normal market price. And we're able to do that by selling our surplus electricity and for trading our carbon credits.
We propose to operate at 3 anaerobic digesters at the end of a 3-year evaluation period. In the conclusion, our technology will be able to reduce impacts of greenhouse gas emission, both from cattle and from during transport, and we will be able to generate inexpensive formic acid and electricity for farmers, thus completing this circularizing formic acid production for agriculture. Thank you.
Thank you both. A great presentation. And now we'll move on to number 9, Samuel Alpert for green fertilizer.
Thank you. We'll share the slides. Thank you.
Yep.
Share our screen. Yes, are you able to see our screen?
I can see your screen, but I don't see the presentation.
Okay.
Yes.
Thank you. Thank you, everyone. This is Team Green Fertilizer from University of Massachusetts Lowell. My name is Bernard, and the other 2 team members are Samuel and Visal. We are advised by Professor Juan Pablo Trelas. The rapid population growth has resulted into tremendous increasing demand for fertilizer. As you see on the graph, over the last 5 decades, the consumption of nitrogen fertilizer has actually quadrupled. But this has been made basically by the fertilizer produced by Haber-Bosch process, which release vast amount of carbon dioxide, both at the production and also at the transportation. And it is a very energy intensive process, and also results into nitrogen runoff because of the overutilization. That's why we innovated a technology which is able to produce a nitrogen-based fertilizer from air and water using solar. Now, as shown in the schematic, the sun provides the energy, and this energy is converted into electrical energy by photovoltaic. And using the plasma power supply, the voltage is stepped up, and that results into creation of the plasma. Now, when the plasma interact with air and water, that generates a nitrogen-based fertilizer, which is nitrates, and that can be absorbed directly by the plant. Now, we have already a working prototype, which is with a very promising results. We are able to get over 1,000 ppm of nitrate. And when you look at this video, so this video shows how the plasma is created and how it interacts with air and water to generate our fertilizer. Next.
Thank you so much, Bernard. So there's a significant market opportunity for our system. We did a market assessment, and we're targeting disadvantaged communities, specifically the small and medium farmers in Massachusetts to start. We then will expand to developing countries worldwide. So the current market players in the space are industrialized commercial fertilizers, the standard solid and liquid fertilizers that are in the market. There's approximately a $20 billion US fertilizer market per year. There are some similar competitors, however, only one of which is in the United States. And the system itself that we're producing is completely different than some of the other competitors. The economics of our system are really great. So just under 3 years, we can provide a great return on investment. We've actually done a assessment using surveys for farmers around the region as well as New York. And what we found out is that the cost for farmers per acre is approximately $500 per acre per year. Our system cost is only approximately around $1,000. And as a result of our surveys, the cost of the system is actually easily able to be supported by the farmers that we've talked to directly and our potential partners and customers for our system. As a result, we can reduce the labor costs, transportation costs, and increase crop yield for disadvantaged farmers throughout the community and worldwide. Next.
Thank you, Sam. So who will benefit from our development? So first, it will be a small and medium farm in Massachusetts. And our primary focus is on the highest poverty rate region and gateway city, including Lowell, Lawrence, and Springfield. And the next, we would focus on a remote area and disadvantaged community in developing country, for example, Uganda and Cambodia. For clean energy transition, our effort is well aligned with DOE net zero emission by 2050 because we use renewable energy as solar energy sources. And this making farming sector more sustainable and resilient, especially contribute positively to local economic development. So what does success mean to us? For us, success is when all farm in disadvantaged community and developing country could have access to sustainable and clean fertilizer at low cost. That is called success. And our plan is that since we already have a working prototype, so next we would install the actual system on the commercial farm within this years. And we are planning to apply for non-provisional patent to protect our technology and innovation. And within the 3 and 5 years plan, we plan to have a commercialized ready product to be available to meet the demand on the market. For our resources, right now we have internal team at University of Massachusetts Lowell. We have support from Rich Different Maker Institute, also Office of Sustainability, and professor and of course our business mentors. We have talked to over 20 farms in Massachusetts and partnering with 5 different farms for our outdoor system installation. We also have a potential collaboration with private company and governmental and agricultural organization as stated here.
Awesome. Thank you
for your time, and please join us with our green initiative to have people, to have farmers in our planet. Thank you so much.
Awesome. Thank you, Bernard, Visal, and Samuel. Great presentation. Headed into presentation number 10, Gavin Colbert, Heat Pump Plus.
Hey, can you hear me?
Yes.
Okay, perfect. Just gonna get up the screen to share. Perfect. Thank you. All right, great.
We can see your presentation.
All right, perfect. Awesome. So yeah, we're Heat Pump Plus. We're 3 seniors at Dartmouth College. I'm REA Londa. I'm here with, if you can see him. Yeah.
I'm Gavin.
I'm Reed.
All right.
Cool. So today we're presenting Heat Pump Plus, which is a social enterprise that is powered by an innovative and mission-driven business model, which leverages technological advances in heat pumps. So heat pumps present a really exciting opportunity to a range of customers to not only lower their electricity bills and reduce their carbon footprint, but it does this through limiting reliance on fossil fuel power boilers for heating. So ultimately, our goals are 3-pronged. First, we seek to decarbonize heating systems in cold weather climates. Second, we aim to lower the financial and environmental costs of heating. And third, bring marginalized communities into the green tech revolution. Our social enterprise is driven by the goals of climate adaptability and climate justice, and we firmly believe that Heat Pump Plus can increase heat pump adoption, lower carbon emissions, and keep all Americans warm. So currently, socioeconomic factors are prevalent in the HVAC market. On the one hand, low-income families can't afford heat pumps and rely instead on outdated and dangerous heating systems. Looking at the facts, 30% of low-income families use a kitchen stove to heat their homes, which leads to over 20,000 fires annually. We also see that race and income are predeterminants of death in fire-related accidents. Children from low-income families are 5 times more likely to die in a fire, and African Americans are twice as likely to die from a fire-related death than any other race. So heat pumps are too expensive for the most vulnerable communities, even though they're the ones who need them most. At the same time, wealthy households who can afford heat pumps aren't incentivized to purchase them because of high costs, low awareness, and poor marketing, despite the fact that there are clear benefits such as safety, lower long-term costs, and the fact that heat pumps offer both heating and cooling capabilities.
All right, so heat pumps are an efficient solution to this problem because they can both do the reverse of air conditioning and they can heat a home. And how they work is that they're sourced from either the air or the ground. It passes through a refrigerant. It goes through a compression valve to heat the air. Then goes through the home, efficiently heating the home, goes back through expansion valve and out. And another source is also the national grid or homeowners' solar units. And so working on decarbonizing the grid will also be helpful on decarbonizing the entire heating system. And Heat Pump Plus, where we fit in is we seek to produce American-made, very Energy Star certified variety of units from single room, multi-room. We could do water boilers. There's a range of options, and we would seek to make it more energy efficient, more eco-friendly, make sure that there's no CFCs in the system. And then as well, we'd seek to maybe use an air purifier or humidifier and overall make a more cheap unit. And then as well, heat pumps sort of suffer from a big misnomer. Like I said, they work both in the winter and summer for heating and cooling, and they are a decarbonized solution for many families.
So what makes Heat Pump Plus a unique business model is that it's a social business that prioritizes those in need. We anticipate getting revenue from the traditional streams in the HVAC market today with local suppliers and private customers. However, our profits will be used entirely to subsidize community initiatives. So we anticipate making partnerships with local community outreach programs, such as Habitat for Humanity, or social retrofit projects like those that are being done by the city of Boston today with other utilities. When we translate that to the numbers, we see that with our bottom-up sizing, assuming that 2.8 million households in New England alone are above or at the median income, 80% of those households can install an electric heat pump. 35% of those would be eligible buyers, with about a $900 heat pump on par with the market at the moment with the competition, and about 4 heat pumps per household. The New England alone is a $2.82 billion market, assuming a 5% market share and the 10-year lifespan of the heat pump, we assume about a $14 million revenue annually. And so just with the 15% profit margin, that's 2,000 heat pumps annually. And for low-income households that maybe have a 1 or 2 room apartment, that's, at a minimum that could be 1,000 families every year that we help with this product. And so while the numbers, at first may not seem significant, there's a big impact in our local home-based community. And we know that models like this work because of models like Warby Parker, which today with their glasses give out free eye care and eye tests to marginalized communities. We know this is also a way of incentivizing wealthier customers to buy the product when they wouldn't have thought about it before. So it helps both sides of the equation. We clean up the grid and we help marginalized communities. And this is exactly how we will define success with environmental or social and financial goals. So thank you so much for listening to our idea, and we look forward to taking questions.
Thank you to all three of you. Great presentation. We are going to head into presentation number 11 to Zaziel Forsyth with Inorganic PCM for energy storage applications.
Hello.
Hello, welcome.
Thank you. I'm going to share my screen right now, I think. Can you see
We can
my
see it.
screen?
Yep, we can see your presentation.
It's like, can I hide this thing?
You can go into presentation mode if you need
How do I
on
do
that
that?
screen. So go back into the PowerPoint that you had.
Yeah, well, I can't, so the top bar is blocking it.
Gotcha. Then I cannot see it. You can drag that bar. Actually, you can move that share screen bar, I believe.
Oh, awesome. Genius. Okay. So my name is Zazie Forsyth. I am a part of the UML student research team here at UMSL, led by Dr. Jan Kosny. I will be presenting on inorganic PCM for energy storage applications. So phase change materials, or PCMs, are materials that change phase. In the case of what we're talking about today, it's solid to liquid, and it absorbs heat and releases heat depending on its melting range and its phase temperatures. So the example that we're going to talk about today is sodium acetate trihydrate. Key properties for phase change materials for thermal storage is the melting range, the latent heat capacity, and the thermal conductivity. Advantages of PCM systems is high latent heat. They are non-flammable and non-toxic, and they have lower costs compared to other PCMs, among others. There are a couple of drawbacks associated with PCM systems, namely supercooling, phase separation, and low initial thermal conductivity. All those can be phased out with the addition of fillers, nucleating agents, and thickening agents. So the technology that I would like to present is thermally conductive heat storage panels. These panels are multi-use, modular, durable PCM-filled plastic products. We also plan on making boards and blankets as well. These panels can be used in areas such as the building industry, the solar energy industry, and as temperature control systems for batteries, and it can be used for cold chain industry applications. So for my market assessment, we looked at the building industry. On the left, you can see a residential home that shows the typical places where heat is lost, mainly the walls, the roof, the attic, the windows and doors. In 2015, the residential electricity consumption was most for AC and space heating. With our PCM panels, that would mitigate how much consumption homeowners spend on these two things. The panels will reduce the overall consumption of electricity, lowering the carbon footprint and leading to a lower monthly bill through improved thermal regulation. Some companies already interested in PCM development are DuPont and Bass, among some others shown at the bottom below. For the economic feasibility, it is projected that the phase change materials market will continue to increase over the next 6+ years, and it will have a growth rate of 17.4%. For the customer, the cost associated will be just the PCM product and installation of the products. For the manufacturer, the cost includes materials, production, and packaging. So potential impact for our product. The benefits are the homeowners, especially low-income families who spend a lot on monthly heating and electricity bills. The environment will benefit through a decrease in usage of fossil fuel for thermal energy. And our manufacturing partners will benefit through new business opportunities, which leads to an increase in profit. This business will provide lower cost PCM products while increasing adoption rate of this technology and promoting conscious energy use. So our business plan, our success is defined as forward momentum towards our set goals. And we have 3 goals as of right now. One is to develop a working prototype. Next is to have a full-scale demonstration. And third is to have 10 working plus projects in 3 years' time. We have most of the people and resources we already need. We have great students here at UMass Lowell and professors who advise us on steps to take and resources that we need. Dr. Cordula Schmid is our market analysis specialist, and she provides all of the things that we need for that. And for our material suppliers, we've been working with Carolina Chemicals, Thermo Fisher Scientific, and Sigma Aldrich, among others, to get our materials that we need for production. And on the right, you can see our production path that we've mapped out. Thank you very much.
Great, thank you very much. Great presentation. We are going to head into our last presentation of our second block of presentations. So it is going to be number 12, Justin Bazemore of Liquid Metal Battery for Energy Storage. Liquid Metal Battery for Energy Storage, are you here? It might not be just Justin. Liquid Metal Battery for Energy Storage going once. Liquid Metal Battery for Energy Storage going twice. Liquid Metal Battery for Energy Storage going 3 times, I guess. Three times. All right, so we'll go ahead and call that the end of block 2. As a reminder, in case Justin or Sunit come on, who was our Miss presenter from the beginning, they will have a chance to present. So our third block may end up being a little bit longer, just as a reference for all of our judges. So there are a couple questions in the chat, so I'm going to go ahead and start with those. And then we will jump into any other questions that our judges have. So startups, we have general questions for you, either from one judge or specific questions. We'll just jump right in. So question for Heat Pump Plus. What is your business model? Will you be a manufacturer of a new type of heat pump? Will you be the installer? Will you sell direct to consumers?
Hey there. So yeah, thanks for the question. We will be a manufacturer of the heat pump and distribute our own heat pumps that leverage technological advances in the efficiency, personalization, and temperature resiliency of the sector and the market as a whole. And while we recognize the challenges of being both a manufacturer and a direct-to-consumer local supplier or seller, we believe that's the most effective way to accomplish our mission of being a social business. We will not be doing installations. We believe that's more efficiently done at the local scale. It's a very transferable skill with local HVAC installers at the moment. And we believe that, like I said, this would be the most optimal way to generate enough revenue to support our social business. And we would look forward to showing more about the design and our ideas in future rounds as we have time to flesh those out.
All right, so we'll jump into our judge questions. We'll start with Susan McKay.
Yes, this is for Fair Fruit and Energy Exchange. I don't know the presenters' names, but
yeah. Hello.
Hi. No, I just had some questions about the actual demand for the end product. So I saw you had really good, efficiency and conversion rates, and you talked about, that you had 100% of the fruit could be then preserved and sold. But does that track with the demand?
That's a great question. So we found locally in Kenya that there was not existing demand. So that's why our production processes with the IoT system are designed to allow us to import it to the US. So there is substantial demand here. So basically snack manufacturers or just people that make dried mango as a business. And then it'll vary by cut size. So they'll either want like chips or slices or circles. But we did find that there is sufficient demand to basically absorb the post-harvest loss issue for the Kenya market.
Thank you.
Francesco?
Thank you, Tali. I have a question for gas farm. So I understand that the solution is like a biogas fuel generator plus electrolyzer. And I'm wondering how your solutions basically will be sensitive to contaminant gases that might potentially be present in the biogas that is produced from the digester. And in case, how are you planning to deal with them and how much that would impact the economics of your solution?
Yeah, so that's a great question. So currently, carbon dioxide reduction to formic acid is really well established at like a TRL 4 to 5 level, so at the lab scale. So as we scale up in terms of implementing a purification system, that is entirely feasible. Gas purification systems exist and are fairly well tested. And as far as economics go, where formic acid is a commodity and the electrolyzer technology for formic acid as a commodity has been fairly insensitive to some operating cost fluctuations in preliminary techno-economic analyses. So we're confident that we can absorb that cost, particularly if we're a bit less conservative with the offset carbon credits and the surplus electricity. So that would be our answer for now, but more detailed TEA would reveal any more insights into that.
Thank you.
Okay, John, go ahead.
Yeah, this question's for the green fertilizer. Can you guys talk a little bit about the competitive landscape, specifically with some of the emerging other green fertilizer technologies that are being deployed in the market today?
Sure. Yeah, I can talk about that. So there's one out in California who basically is a little bit parallel to us in the development stage. They're actually deploying a pilot, I think, out in the field. So we're kind of parallel to their process, although we're in the East. The others actually there's one in Norway and there's one in another country that I don't have off the top of my head. But basically the difference with our system and theirs is basically our system has primarily solar panel use of generation of electricity. We are able to store the nitrates afterwards. Basically by storing it, we can enable the increased production. And also another aspect of it is the different modes of plasma generation. So our mode is a little bit different, and one of my colleagues can talk about that a little bit more. And also another thing that we're looking to do that's unique is we're trying to lower the cost, and one of the ways to do that of solar panels themselves is to look into ways that we can utilize recycled solar panels or solar panels that can basically be reused. So let's say you have a house that installed solar panels 20 or 30 years ago, but now they're looking to double their capacity by increasing the by installing the same square footage, you can basically double or triple the capacity nowadays. So, some of these older systems, even if they're not completely unusable, we could potentially reuse for our use.
Thank you.
John Clavins?
Yeah, two more quick questions for green fertilizer. One is just compatibility with organic farming. Couldn't tell if it was. I assumed it wasn't, but I wasn't sure. And then the other is I also couldn't tell whether the technology was designed for on-site production of fertilizer by farmers for themselves, or whether this was the technology for centralized production that would be distributed to the farmers.
Yeah, I'll start with the second question. That one's an easy one. So yes, it's on site completely, and that's one of the big benefits to it because it's distributed generation of the fertilizer. So we're reducing transportation costs and emissions in that sense. And one of the biggest things about the current fertilizer production process is that there's a significant amount of carbon generated because it's a high temperature, high pressure process that's located, in maybe 20 or so, 20 to 50 places throughout the US, none of which are in Massachusetts. So even in Massachusetts, you can get fertilizer cheaply in the stores, but, in terms of the manufacturing of it, it's not local to, the farmers, generally speaking. And then the first question about organics. So we've actually talked to a few different people about this, and this is actually something that is worth exploring further. There's no definition of organics that says that our production is not organic. However, it would be up to the certifying entity of the organic, fertilizer business per se, to be able to, distinguish our product compared to, the traditional fertilizers that are available on the shelf. So it's not a traditional organic fertilizer, but there's nothing, the only thing that's producing our fertilizer is renewable energy, which is like I said, a renewable energy source, which in a sense is organic.
All right, we have one more question. We have time for one more question from Dan. Dan, are you there?
There's actually a question from Judge Linda.
So I had I had a question for inorganic PCM. It was a really interesting explanation of science. A little bit about the path to market. So you identified some building materials partners. What's your thinking about building this yourself in terms of actually manufacturing the components versus licensing your technology to those potential partners and potentially speeding up the commercialization? Why'd you choose the path you chose?
Can you hear my friend Jay?
Can you just repeat the question? I was unable to get it.
It's actually in the chat, so take a look.
All right. I cannot see in the chat the question.
So
I think you sent
quick
it
question
directly
is-
to someone.
Yeah, the quick question is, why build a manufacturing facility to make these components as opposed to licensing the technology to companies you've already identified in your slide deck who are interested in this technology and already manufacturing components?
Okay, the thing is, like, we are focused on the PCM material with all different temperature range. It's not particularly that we are focused on high temperature. And when we are manufacturing this all PCMs and bringing to the market, so we have a industrial partner for our project as well, and who is gonna get involved in this once we get with this PCM prepared for durability with all the properties which we want. And when we are going to use this PCM with different packaging stuff, it will be used with on the ceilings, on side walls, or in the like flooring purpose, where we will be able to get the advantage of the energy from the PCM. And that particular product, by commercializing it, it will be supplied to the market, through which we'll be having a lot of advantage in energy consumption usage, and we'll be able to decrease the bills, we can say electricity bills, through the HVAC system, which is a lot in today's scenario.
May
All
I
right,
just still
thank
ask
you.
a question? Because now I believe you can be, or we're out of time.
If it's quick, you can ask.
It's very quick. Two questions to the CHP fruit dehydration. First, is your technology, CHP technology, unique, or are you borrowing from existing technologies? And second, why so highly focused, which is good, but there are so many potential other usage for CHP heat and power?
Yeah, so this is a village scale combined heat and power plant. We partnered with Village Industrial Power. And then basically, so the idea was to provide access to renewable energy using agricultural waste on small farms. So it's unique in that application. And then we found the most profitable productive uses. And the most profitable is actually dehydrated mango. So it's that specific in order for us to get proof of concept in terms of the commercialization model. So the profit of dehydrating fruit has to be enough to offset the expenditure of the generation unit, as well as the crop dehydrators, and then the housing structure as well that it has to go in to be compliant.
Got you. Very interesting. Thank you.
All right, thank you, judges, for great questions, and presenters, great presentations. We are headed into our third block. We are about 10 minutes early, so I have just emailed our third block presenters to make sure that they're here. So if our very first few presenters are not here, or if the time gets a little bit shifted, don't worry, we will make time for all of our block 3 presenters. And this is the part where I start skipping numbers. So I promise I will hit all of our startups, but I will be skipping some numbers. So our first up for our third and final block of presentations is number 13, Michael Ganjemi, Mesophase steam condensers.
Hey there.
Hello.
All right, Yejeng, are you on too?
Yeah, I'm on.
All right, let's do it.
I can see you on the screen. Is that okay?
Oh, yeah, sorry. Yejeng is presenting first. Could you pin her? Tally.
Yep,
thank you.
You're all set.
Thanks.
Hello, everyone. We are Mesophase. We develop energy efficient steam condensers for industry like power plants. Majority of global electricity is generated by thermal power plants. However, many of them are not operating at the best efficiency feasible. Next slide. Energy efficiency of thermal power plants is determined by 2 temperatures, hot side temperature and cold side temperature. It's usually hard to increase the hot side temperature, especially for geothermal power plants. And as comparison, it's easier to decrease the cold side temperature by having a more efficient condenser. And that's what we are going after. In industry, condensers are usually made of flat metal tubes, and water will form a thick liquid film and generating a big resistance to heat transfer. With Mesophase, we want to improve this process by having our enhanced surface for heat transfer. And with that, we can improve the overall heat transfer by over 50%, which translates to over 7% increase in power output. Our technologies have been developed in the lab at MIT under fundings like DOE grants. And to date, our best data shows over 7 times heat transfer as compared to a conventional condenser for a lifetime of over 200 days in environment that is similar to a power plant. We use low cost and scalable technique to make the surface, and we see a future to scale up the technique and make it cost efficient in scale. We are planning to offer a full condenser unit to our customer, which would be power plant owners. And we also supply aftermarket support, such as tube replacement. Mike.
Yep, the market for steam shell and tube condensers is relatively large globally. Across the 3.4 terawatts of global steam energy production, it's about $130 billion market, factoring in the 2.5% improvement we see on average across steam power generation. Obviously, that's a huge market and not one that we're going after initially. Even in the US, it's a $20 billion market. All that said, I think the best application for our technology initially is in the geothermal space. And that's because of the constraints that Yejing mentioned earlier, where the hot side is really limited by the heat of the earth, and there's real constraints about growing that. So we see a $200 million opportunity in the US. We also see relatively attractive economics in our condensers versus conventional condensers. So a conventional condenser costs around $20,000 per megawatt to manufacture. And pricing is quite varied, but we see an average price around $30,000 per megawatt. So relatively constrained margins, and relatively high willingness to pay for some constrained cases like air cooling, where there may be no water. We plan to price at $50,000 per megawatt, so well within that range. And we also hope to share value through the incremental power generation with our customers. So we're roughly splitting the value generation 50-50 with the power plant user. We also don't see much of an incremental cost versus traditional manufacturing because of the relatively inexpensive materials. So as I mentioned earlier, we see geothermal as the best initial use case, and we started talking to customers in that space and generated some initial interest. The rationale is, again, that the hot side is very constrained in geothermal, so there's greater value for cooling efficiency. And that's that's complemented by the fact that geothermal plants tend to be pretty small. So it favors an early approach for us in trying to find a pilot partner where we can generate data, but not have to build a giant condenser. That said, we do see applications across a broader range of technologies. And the long-term application for this technology is kind of across fossil fuels and nuclear as well. Obviously, big tailwinds for energy generation going forward, and we see this technology as a good fit for both growing energy demand and also a need to move away from traditional technologies like once-through cooling and fossil fuels. This is just an overview of some of the customer feedback we've heard, which generally supports kind of everything I've said, which is to say there's a real need for better cooling technology, and power plants and utilities are looking for new technologies to put in place. Yejing, you're muted.
We are seeking $400K for early stage funding, basically for our prototype, scaling up, and also team building. And we plan to have our first full-scale geothermal condenser in the field by 2030. Next slide. We are a team combined with years of experience in technology and also in business, and we are passionate about energy tech commercialization for a better world. Thank you.
Thanks so much.
Thank you both. Great presentation. We are headed into number 17, Nicole Eaton of the Roll-Up Roll-On Solar Panel.
Awesome. I'll share my screen. Can y'all see this okay?
Yes.
Great. Okay, so we are Verde Technologies, and we are producing a thin film solar panel. Oh, it looks like my thing can't move with the share, so let me just, oh, there we go, space. I'll back space a little. Okay, there we go. Wait till it goes there. So the problem is installing solar is expensive and sometimes impractical or impossible. And so this goes with curved roofs, intricate design roofs, membrane roofs, and low weight roofs as well. And so also 80% of Americans can't afford solar. And this is because up to 75% of the cost is installation, system design, and permitting. So this is why our solution is a thin filmed deposition technology developed at UVM that's an amorphous silicon perovskite tandem. You can mount it anywhere, even on irregular roofs. It's also customizable for all roof types. It's 75% lighter. There's no load concerns. It's highly efficient. We have 28% efficiency right now in the lab, which is already better than other thin film solars out on the market. And lastly, it's affordable. So there's less costly system design and installation. Ooh, there we go. So our current market is very crowded right now with companies in the thin film solar industry, but the problem with that is that they're all mainly focused on traditional rigid panels. And so for the US markets, we're looking at mobile homes, farms, and eventually big box stores. And so for this, there are 4 million mobile homes out there in America right now, but they can't have traditional rigid panels due to the weight and size. Also, with farms and silos, it's a good market, although we don't have an exact number for that. Just by driving around Vermont and New England, you can clearly see that there's a huge market for these, but they can also not have traditional rigid solar, just due to the size and the weight. And then lastly, eventually box stores. There's a huge mounting ballast system that's really heavy. And with our adhesive and roll-on solar panel that's lightweight and flexible, this will reduce that problem. So here you can see that we've already had a deep analysis of all of the flex thin film solar panels in the market, but you can see where we really thrive is in efficiency and price per watt, which I'll explain later. But this just really highlights why we have a competitive edge on these other thin films in the industry. So for our business model, we will be the main supplier. We will have a contract with the manufacturer, and we also already do have a manufacturer. They're Flexcon, based out of Spencer, Massachusetts. So we will then supply to the installer, and then the installer will be responsible for marketing and selling to the homeowner. So the go-to-market strategy. So first, we just want to create a network of manufacturers. After that, we'll work with manufacturers and installers to test installations on mobile homes and curved roofs. And then we'll expand our network of installers and install across a greater population. We will then install on commercial sized roofs as a replacement of those heavy ballast mounting systems that I mentioned before. So who do we want to sell to? We want to sell to solar installers, and we really want to highlight our special qualities, which are our architecturally versatile solar panels that are highly efficient, American made, affordable, and lastly, easily installable due to our adhesive backing. So for a cost breakdown, for a 10 kilowatt residential system, traditional solar costs about $30,000. As you can see on the graph, there's mounting, manufacturing, installing, and permitting. And so we can reduce those costs by 25%, making our thin film solar system $22,500. We are also producing our thin film solar at 82 cents per watt, which is roughly similar to the other thin film solars out there, except we do have our competitive edge once again, which is affordability. So the money we need for success, we do need $500,000 roughly. This would be for research and development and also pilot manufacturing with Flexcon, who is our partner. And we do this by accelerator programs such as SBIR, as well as prizes. We've been doing the Perovskite prize, tried to get it for roughly 6 months now. So just continuing to do those. So our end goal is just making energy possible for everyone. So our metrics for success are achieving lower total system costs than current solutions, improving system payback time to under 6 years, and then lastly, just having a product by the end of 2024. So here we already have business advisors and manufacturers like Hula and Visa and Flexcon, but we really want to fill this gap of local installers, and we hope that this program can help with that. So thank you, and please join us on our mission to affordable solar.
Great, thanks, Nicole. Great presentation. We are moving on to number 18, Will Jeffries, Underground Infrastructure Scanning and Mapping.
Awesome, thank you very much. Audio check?
Yep, I can hear you.
Great, bringing up the presentation now. Sharing screen. And how is that working for everyone?
I can see your presentation.
Awesome.
Whenever you're ready.
Great, thank you. My name is Will Jeffries, and I'm here to discuss how our company, DeepSense Technology, is enabling the energy infrastructure both now and for the future. Almost every element of modern life is dependent on infrastructure, and the energy transition towards a more sustainable and resilient economy will require a massive overhaul of these systems, a large part of which lie buried under the surface. One of the biggest challenges facing infrastructure improvement is navigating the labyrinth of utilities already underground. What we have heard again and again from national studies, as well as those working in the field, is that the information currently available to locate utilities is routinely inaccurate, wrong, or missing entirely. This problem results in massive delays, disruptions, and damages that affect every level of our society and economy, costing over $61 billion in damages in 2019 alone. Our solution is a scanning and mapping system, utilizing our already patented sensor technology integrated into existing platforms to scan the site, upload that information to our automated analysis, and then deliver reliable information for accurately mapping underground utilities. In essence, to provide an effective map of the underground, one that reduces the risks, costs, and contingency fees that currently bog down infrastructure projects. Our go-to-market strategy is to partner with an existing ground-penetrating radar equipment company and to integrate our technology into a new line of radically more effective underground scanners. This integration would have a relatively minimal effect on the cost of manufacturing, roughly $1,300 per unit, while our customer discovery and market research indicates that the capabilities that our system introduces raise the value of this same product to at least $60,000 per unit for the end users in the field. The benefits include improvements in scanning speed of 8 to 10x, accuracy under a variety of soil conditions, greater depth and resolution, as well as an automated analysis process. Working with this industry partner, we would be providing a highly valued scanning capability to surveying companies, as well as engineering firms, utilities, and municipalities themselves. This table shows the qualities of currently available solutions that our customer discovery has indicated to be very important and frequently dissatisfying to end users. Our solution satisfies all of these requirements and does so at a significant cost savings. In this projection, a retail price of $60,000 per unit sold with our integrated technologies has DeepSense Tech earning a 5% royalty on every sale. DeepSense Tech also earns an ongoing revenue of $1,500 per year from the end users for the ongoing value of our software as a service data analysis. The specific market that we are addressing stood at $531 million in value last year and is projected to grow at a rate of 8% over the next 5 years. With an industry partner manufacturing and distributing, DeepSense Tech can focus on our strong suit of data processing, improving analysis methods, and continuing technology development. The largest parts of our costs are in salaries, such as research, analysis, and business operations. We're also planning to base our company in a designated opportunity zone of Springfield, Vermont, a depressed community, but one with a growing business hub that can help to revitalize this area, and also happens to have an ultra high-speed internet provider for transmitting the large amounts of data. These are a few of the industry suppliers that we are working to develop partnerships with and examples of potential early adopters, as well as major surveying organizations that we intend to see our technology used by. The 3 points that we believe help to define our success in this venture include demonstrating successful integration of our existing technology with a partner's product line, achieving economic sustainability within 3 years of project launch, and the adoption of our solution by one of the top 5 surveying companies in the United States. Important resources that we will need to achieve these goals include hiring expertise, seed funding to build our minimum viable product, and developing our equipment production partners to mass produce and distribute the solution. Green check marks indicate resources that our venture has already assembled, both the technology and business development teams in a professional workspace, and our standing LLC is already contracting with multiple paying customers who are helping to test and pilot the system in the field. To bring this all back, almost every energy technology is reliant on infrastructure, either to operate or to deliver. The impact of our venture as a success would be to reduce barriers of cost and uncertainty for nearly every field. And at the same time, our solution would help to improve conditions for those most in need. Our underserved communities often bear the largest burden from a lack of affordable services and lack of opportunity, both of which our solution can help to enable with the coming energy transition. My name again is Will Jeffries at the University of Vermont with DeepSense Technologies, and I look forward to your questions.
Thank you, Will. Great presentation. Now our our presentation number 19, Ketty Cormier with Water Without Borders.
Hello, we're just gonna share our screen with you now.
Okay, great. We can see it.
that
You're
okay?
all set. Yep.
Awesome. Hi, my name is Ketty Cormier. I'm here with Brooke and Gwen. We are representing Engineers Without Borders from the University of Maine, and our project is called Water Without Borders. So who are we? We're obviously located in the Northeast region. We attend school in Orono at the University of Maine, and we are an Engineers Without Borders student chapter. So we're a group of students who use real life like engineering skills to do work in third world countries. Currently, we have a project in Honduras, which we are working on a septic tank system. So our proposal for you today is the use of a wind or solar powered water desalination unit for low income communities with water insecurity. A primary and reliable method for water desalination is reverse osmosis. Our idea is to use solar panels to collect energy from the environment, and using this harvested energy, the pumps would push seawater from the ocean to the community. This feed water would pass through a series of microfiltration membranes to remove larger particles before passing it through the RO membranes, which would complete the desalination process.
Hi, I'm Gwen Armitage. So the business model consists of building the reverse osmosis units. There are 2 units that we would have. One would be located near the intake where the ocean water would be. And this would be where all of the pre-filters are and the pumps. And then this would push it up to the house where it would have the desalination system. So splitting the system up like this makes it more customizable. So if a house is like a couple streets away from the ocean, it can still have access, even if you're not someone that can afford like waterfront property. We would also have our system be very easily repairable and maintainable, all like very standard industry products. And we would supply the filters for when they need to be changed. And overall, this would be able to last our customers a very long time. And our target for this business model is also, as we mentioned, lower income communities. And as the community is larger, it's also more affordable. So everyone needs water everywhere. And so we would have no shortage of clients for this product, especially as if we can make it as affordable as possible. So some of the engineering aspects, we've taken a lot of our facts and information for this business model from a capstone group at the University of Maine, and they are completing testing and other experiments on this desalination system. And we have a schematic drawing shown in figure 3 and some various bullet points about some information about it. And the cost of our unit would vary based on the location. So for our capstone group, all of the information is coming from a community that would be located in Maine, but it would be more cost effective for communities that are located, say, in Arizona, where there's a much more reliable source of sun. And so on this slide, we have a graph that shows the theoretical water production that we could get for, again, a community that's located in Maine. And we took all of our data from TMY3 and we used various equations to calculate the theoretical water production. And that's around 330 gallons of water per day would be the maximum water production that we could get in Maine.
And now we're going to go over some facts about water scarcity in the world. And so these are some pretty alarming facts that show how important this issue is. So there are 884 million people that lack access to clean drinking water, and there are about 4 billion people who experience severe water shortages at least once a month. And then about 70, by the year 2025, it's expected that we'll be using about 70% of the Earth's fresh water supply. So it's really important, I think, that we take advantage of this equipment to start using salt water. And these are some of the resources we've used while researching this topic. And we're looking forward to your questions.
Thank you.
Thank you. Great presentation. We are headed into presentation number 20, Phoebe Fallon of monetizing a latent energy source, plastic waste. Phoebe Fallon of monetizing a latent energy source. Monetizing a latent energy source going once. Monetizing a latent energy source going twice. Monetizing a latent energy source going 3 times. Okay, we will circle back to the 3 presentations that have been unable to make it thus far, and we will move on to what could be our last presentation of the day. Ella Dem? Sorry.
No worries.
And you are all set to go whenever you're ready.
Got it. And Stella, I believe she's on the call as well.
She is.
She is? Okay. I'll share my screen.
All right.
All right, I can hear you both and I can see your presentation. So whenever you're ready.
Awesome. So hi, my name is Stella Stark.
My name is Ella Gokchidan.
And we are Team Bloom.
So algal blooms is a phenomena that plagues coastal regions all around the globe wherever there is nutrient pollution, and these algal blooms create a byproduct called sea mucilage. And unfortunately, this past summer, the Marmara Sea in Turkey encountered the largest sea mucilage crisis in historic data, and it essentially choked off the oxygen levels near to zero and left a massive dead zone that future generations will have to deal with for many years to come. And unfortunately, as drastic as this event was, unfortunately, government funding and collaboration with research initiatives, researchers were able to create a very innovative technology to convert this sea mucilage that causes such massive ecosystem disasters all around the globe into something very innovative, in which Team Bloom plans to scale here in the United States.
So kind of a brief overview of what we plan to do would be to partner with government organizations and nonprofits to collect the surface algae. We would then be leveraging hydrothermal carbonization, which is a technique that uses hot compressed water to extract water and carbon dioxide from wet biomass, leaving behind a carbonaceous solid known as hydrochar. This has been shown effective for use on algae by Turkish researchers. We plan on further innovating on hydrothermal carbonization by using direct solar thermal heating to provide hot water, keeping the process centralized. This hydrochar can then be burned to generate energy or utilized as an alternative for green grills, fireplaces, etc.
Looking deeper into the cost analysis, there are currently many initiatives around the globe, specifically focusing on Florida, where red tide is a very common algal bloom that most of the United States knows about. There's a lot of money going into prevention, mitigation, and cleanup as well. And algae is also a huge buzzword for fossil fuel companies that are looking forward to investing more into the biofuel sector. So it shows us that there is a pre-existing market that we can tap in, not only with algae, but pre-existing algae. So there are many pain points of the hydrothermal carbonization method. So the first one would be the cost of heating the reaction. It is very energy intensive, and that increases the cost of that input, and as well as the cultivation of the algae in pre-existing research methods for the HPC process. People have to individually farm and grow their own algae in order to convert it. And that also increases the cost of the inputs, so it makes it very inefficient to compete with coal, which is a very cheap alternative since it's subsidized and also doesn't account for the full external costs. But that's where Bloom comes in.
Yeah, so in regards to the cost constraints, because we're using a direct solar thermal system, this cuts down the cost of electricity as we aren't reliant on the grid to heat up the water, as well as the low cost of retrieving the pre-existing mucilage. This price would also be competitive in the market because it's an eco-friendly alternative to small-scale coal, which will incentivize customers to pay a slight premium, if any, in order to protect the community. So it also protect ecosystems by using pre-existing algae, which would reduce the cost of input and become one of the first initiatives to monetize the collection of mucilage.
So looking deeper into the cost analysis of pre-existing data on HTC methods, as you can see, it could be a very cost-intensive process, but since the researchers in Turkey this is a very new and up-and-coming technology that Turkish researchers are still integrating into the government there, this model just considers the pain points that we talked about earlier, which Bloom hopes to mitigate in the future. And regardless, it would be a very monetized, like heavily monetized project, but it's important to notice that this could be a one-time investment that will generate a return on investment throughout the years once it's integrated, which again, as Stella mentioned, would be the first ever to monetize and incentivize the cleanup of algae and also utilize pre-existing government funds and find a more efficient way to clean up algae, since right now people just let it go float and disintegrate over time and it comes back seasonally. So we would get a constant regeneration of our product and input. So going into our expansion strategy, as you can see, as we mentioned, the coastal United States is impacted by this, and we hope to specifically focus on Florida in the future. And Stella can talk about the benefit.
Yeah, so it will benefit the ecosystem by reducing the amount of surface level algae, will allow the ecosystem to have a boost to regenerate itself. It will also help the community by benefiting tourism, collecting water sources, will help prevent mass health issues caused by the toxic algae, aid marginalized communities, and benefit small-scale fisheries. This also provides a gateway into the renewable energy transition. It helps the climate by keeping carbon dioxide more in the loop as opposed to releasing new CO2 with coal. It will also allow the ecosystem to perform its functions in helping the environment.
Going deeper into the implementation strategy, and so as we mentioned, we're focusing specifically on Florida since there's ample sunlight, which would help our direct solar thermal heating method, and we will convert this through our HTC process and hopefully sell our products through direct-to-consumer methods and also help donate our products to help raise awareness, use our company as a platform to raise awareness on the climate crisis and how marginalized communities are really impacted by and how they're forced to use unsustainable fuel sources when we could help create such a drastic thing and find a way to convert it into something that people can use for energy in the future. So in summary, Bloom will leverage this process that is up and coming and is very innovative and bring it to the United States, where we can collaborate with the public and private sector to raise awareness on algal blooms and make sure that the communities that are impacted by this the most will find a way to incentivize and monetize the cleanup so they could help sustain their lifestyles for the future. Thank you so much.
Thank you.
Great. Thank you both. Great presentation. That ends our presentation list. I am going to do a quick call out for the 3 teams that missed. Is Agrosol AI Sunit Bindra on the line? Okay. Is Liquid Metal Battery for Energy Storage Justin Bazemore on the line? Okay, is Phoebe Fallon of Monetizing a Latent Energy Source Plastic Waste on the line? All right, it looks like we have ended our startup presentation. So I want to say congratulations to all of our startups. I know that it's pretty hard to come on to a meeting like this and give a big presentation. So congratulations, you gave wonderful pitches to a room of 60 people, which is awesome. It takes a lot of practice and rehearsing and a lot of time to put together the wonderful presentations that you all did. So I want to congratulate you all and remind you all that no matter what happens with the deliberation here, that all of your ideas sound wonderfully feasible and like they're going to make a difference in a lot of different communities. So please don't take this as being your final step. I hope that you all work towards creating your vision and really making a difference. So congratulations. I am really excited that you all are our future. So let me add us our Q&A time. Thank you to our quick judge message. I got very excited. So we do have our 10 minutes of Q&A that we will do. So this is going to be on our last 5 teams that presented. So that's Mesophase steam condensers and the roll-on solar panel, underground infrastructure scanning and mapping, water without borders, and Bloom, algal cleanup and conversion initiative. So all of those teams. I hope that you are still on the line to answer our judges' questions. I think that there was one in the chat, if I remember correctly. Let me make sure. Okay, I think that one's from the last one. I think that we are all set. So we'll go ahead and start with Susan. Go ahead.
I had a question for roll-up, roll-on solar panel. I feel like I must have missed it, but what I recall is the installers would be in charge of marketing your product. And so I was trying to understand in your business model what the incentive was and what the profitability is for the installers. So how do your interests align with them?
Yeah, and so we were thinking of kind of marketing to them in the sense of it's really affordable. It's affordable for them to buy off of us. And it's also, it would get them a big market in terms of homeowners being really attracted to the affordability, since they don't need to mark up that price. If that was your question, we'd also, I had a slide on there, basically just going through how the efficiency is also super high. And so being a solar installer, it's pretty, reputable if you have a highly efficient solar panel that you're willing to install. Also, a lot of homeowners don't want to pay for those really high installation costs, nor can they afford to. And so by having the solar installer tell their client or homeowner, hey, we have this flexible solar panel, no matter the house, we can roll it on. The efficiency is 28%. It also is affordable. And so it's mostly the affordable aspect that they'll market to the homeowners, but we also are going to market to the solar installers, those specific scenarios of, hey, you can get a bigger base if you kind of are marketing what we're marketing to you, which is why they should get our panel. I hope that answers.
So, well, sort of. So would they be able to charge, would they get a higher profit margin selling your product than another product they might install? And would it reduce their labor costs or need fewer laborers if it's a tight labor market? I'm just curious. I guess that's more where I was going.
Yeah, I mean, it's definitely a market that we definitely need more research in for sure. Just because it's like a very new product. But I will say that, yeah, it honestly, it really does depend. And I don't have exact answers for that question. But I will say there's also, potential for this solar panel to be self-installable. So it might be that an installer could be, hey, like they would obviously get a percent, maybe less, but they could also go to a homeowner and say, okay, if you don't want to pay for my installation cost, you can give us a little bit less money, but you're going to have to install it yourself.
Okay, thank you so much. Nice job.
So Nicole, another question for you. Did you say it's 28% efficient?
Yes. So right now in the lab, it is at 28% efficiency.
So conventional solar panels are what, 21 to 22%, right?
Yeah.
Okay. So this would be a breakthrough product. Why wouldn't you go after the entire Bridget solar panel market that's valued around $10 to $12 billion? There's got to be a big catch here. What would prevent you from going after that market? And why wouldn't this be some breakthrough technology that everybody would adopt in conventional and other applications?
Yeah. I mean, the thing right now that we're facing is the durability of it. It's right now cannot last as long as traditional rigid panels are lasting.
What's the life?
The life, I would say it's probably, right now we're thinking probably like 6 years, which is short. And so we're trying to get over this obstacle of not necessarily going to this, breakthrough product, just because at this point it really isn't due to that durability, because there are a lot of people who can afford traditional solar panels, or they don't want to go through necessarily, although it's easy to install since it has an adhesive and you can roll it on. There are a lot of people out there, which we do need to do more customer discovery, but who don't really want to go through the process of being like, oh, okay, this solar panel is losing efficiency, I'm going to have to install a new one. So that's definitely something that we're facing right now.
Thank you, Nicole. Good job.
All right, Linda, go ahead.
I have a question for Bloom. What volume of algae do you need to collect to yield what volume of hydrochar? And is there anything about hydrochar that makes it burn either more efficiently or cleaner than other kinds of fuel stocks?
Yeah, I mean, I could go into the amount of algae we could produce, and Stella, if you want, you could talk about the carbon content of the hydrochar. So basically, based on our research, again, since this is a very up and coming technology, the Turkish scientists were the first to ever primarily use the mucilage specifically in this process. So the data is still coming along as we speak right now. But as we were able to do research, it seems that 2 tons of mucilage, which is produced about every 3 weeks, with the algal bloom given in Turkey, it produces about 50,000 kilograms of hydrochar. So it's a low turnaround, but again, like just considering how there's no incentive to clean it up as of right now, it would just provide a little return on investment to the ample amount of funding going into just cleaning it up. And Stella, if you want to talk about the carbon content.
Yeah, so through the process, you're left with a product that is almost pure carbon, so it burns very cleanly and very efficiently.
Oh, just adding on to that really quickly too, it was really interesting finding out how the HTC method also removes bacteria and toxic substances, which was the main concern in this whole process as well, since mucilage, can combine with like chemical pollution as well. But once it's heated up, it essentially removes all of it into pure carbon, which is very efficient when you look at it from a systemic lens.
Thank you.
Is that everyone's questions?
It looks like John Clavens has a question.
Okay, go ahead, John.
Yeah, I had one more question for Nicole at Verde, picking up on the discussion from before. So if you're expecting that the thin film PV would have to be replaced every 6 years, is there anything else that you figured out that might still make this economic? For example, focusing on some of the one-time costs of installation that wouldn't have to be repeated with replacement of the film. For example, upgrading the house electrical, permitting, interconnection costs, anything along those lines.
Yeah, no, definitely exactly what you just said. But another advantage of ours is we're also trying to expand on the possibility of putting our adhesive over panels to raise that efficiency. So if you don't want to just totally strip off your solar panel and pay for a new one to come on, we're also discovering the possibility, which is quite high right now, of just putting a layer on top of the previous one, just because it does have that transparency and can raise efficiency as well. I'm not sure if that answers your question exactly, but that's definitely an avenue that we're looking at right now.
Thanks.
All right, judges, do we have any other questions? It is looking like no. One of our presenters was starting to log in, so I think they might be having technical difficulties. I just want to take a couple minutes and see if they are able to join us to present. So if there are any questions, if anyone has anything that they'd like to ask, now would be the time. I really want to see if we can get everyone to present that signed up.
Maybe I can ask an additional question if there's a minute to fill in.
Yeah, Francesca.
Yeah. So actually, I have a question for Water Without Borders. And I really like the approach to use some of the systems that are already out there to facilitate reliability of the systems, maintenance, etc. And I think it's really necessary in that industry. But I'm also curious to understand a little bit better how your solution is unique. If you can elaborate a little bit on that, it would be fantastic. Thanks.
I would say that it's unique because we are catering it towards the more lower income communities. So ideally, we would be gearing this towards communities that we work on with Engineers Without Borders, but this product could also be applicable to the lower income towns. And that's, I think, what kind of makes it different, because right now there are a lot of desalination units on the market, but they are quite expensive, and they are typically more for just like families. And all of the research that we do have currently is for family, because it is based off a capstone project here at UMaine, but it is something that we can expand to be for smaller communities or smaller towns. So that's, I think, what makes it different from some of the stuff that's already on the market right now.
Thanks a lot.
All right, I am very excited to call Joe Simon to the stage to give a little bit of a hello, hi from the DOE.
So hi, everyone. My name is Joe Simon. I'm at the National Renewable Energy Lab and am supporting the Office of Technology Transitions in this inaugural year of the EnergyTech University Prize. And this is our first Explore event in the first year of a program that hasn't existed before. And I just want to thank everyone involved. So from CleanTech Open to all of the judges who are spending so many hours today and looking at the submissions, to all of the students who thought about how to present your business model, to explain your technology and your passions. It's just so exciting. And so thank you for the time. Thank you for your participation. Our goal with this competition is to build the energy ecosystem. So we do hope you participate in the networking opportunity, that you do think about who presented, you do think about who was judges. And so whether or not this particular idea or this particular business plan moves forward or not, I hope that the relationship and your experience does move forward. So please continue engaging with CleanTech Open, engage with those names that you see here, look at the different areas of interest, and just thank you so much for choosing to participate in this and for all of the time that you spent today. So welcome, thank you, and we're really excited to have you here.
Thank you very much, Joe.
Our very last presenter is stuck in the waiting room. So give me a moment while I try to get them in. We are running a little bit ahead of schedule, so we are not behind. There'll be no pressure on our judges or our networking event.
So while Tally is doing that, I just want to let you all know what's coming next. So after all of the presentations have been completed, we will have a little overview of CleanTech Open, and I am really excited to introduce all of you to 3 of our recent alumni who have done very well after completing CleanTech Open. They all have really unique stories about what they've worked on and how their business has benefited from going through our accelerator. And then we'll have a chance to network with everybody. So stick around. As I said before, this networking is an opportunity to meet someone who could potentially help propel your business forward. And I wanted to echo what Joe said too, and just to say these presentations have been very impressive, and really, really excited to see what everyone is working on, and to know that you all are our future. It's really been a pleasure to watch.
Okay, I don't want to hold us in this waiting period for too long, but I do want to give everyone that signed up the opportunity to present. So I hope that you are all feeling all right with waiting a couple moments. I know that it's not ideal.
Can she join with her phone?
They're stuck in the waiting room. I told her to close Zoom and come back, but I cannot really do too much to fix the Zoom issues. exactly, the Zoom purgatory. Well, I can explain what's going to happen after we finish with this kind of purgatory moment. I will be opening up breakout rooms, but they are not open to everyone yet. So the reason I will be opening them early is to put all of the judges in one room so that we can discuss. The rest of the Zoom rooms are labeled with the categories that you have the opportunity to be a bonus prize winner in. So building technologies, geothermal, fossil energy, nuclear energy, solar energy, water power, and then I added an extra called agriculture and land use because I thought it fit a little bit. I will not be assigning anyone to those. You have the choice to go into those or not. You can go into different ones. You can see who's there and decide to join or not. But those, as much as they will be open, they are not to be accessed by anyone other than the judges until you are told to do so by Beth and Sophia. It's just a quick housekeeping thing for you. And again, I want to say great job, presenters. I know I got excited and said it all before we did our final Q&A, but you really all did a very great job. It was nice to see a lot of different formats of presentations too. I think it's good to see all kinds of different layouts and structures. And I'm not sure that we can hold out too much longer for the Zoom purgatory issues. Beth, do you want to say something while we're waiting for one more minute?
Yeah, I just emailed her to see if there might be another way. But yeah, I want to echo what some of the folks are saying here, that that the presentations were really amazing and very, very impressive. So I'm super excited, and I do want you all to stick around because we're going to tell you a little bit about Cleantech Open, and really we have a lot of we offer a huge opportunity for early stage startups like in your case. I think all of you are relevant for Cleantech Open, so I hope that you will stick around. In the meantime, while we're waiting, I can tell you that I can put a couple of links in the chat. So we are currently accepting applications, and you can look at cleantechopen.org, and I'm going to do something which I don't always do, but I will share with you that we have a media kit which we've created for this year, and it is also in the chat. Our media kit has information that really is relevant about the entire program, as well as many of the events that we have coming up. I know that some of you are from different states. We have state-focused events as well as general events. You are welcome to come to any or all of them. There is no limit based on if it says that it's for a specific place. Don't worry about it. Everybody's welcome to all of them. There will just be a little bit of an emphasis about the ecosystem in the places that are mentioned in the media kit. Also, to let you know that we have 2 specialty prizes this year in addition to 4 general prizes. We will have we're going to be giving away $60,000 in the Northeast, and that's 4 $10,000 prizes for general, any category, and then 2 special ones. So the 2 special ones are carbon sequestration, and the other one is ag, food, and land use. And I'm going to just call on Francesco for one moment. He's one of our judges today. So Francesco won the carbon sequestration prize in 2021. It was our first year running it. And he's not on our agenda specifically, but since we're waiting a moment, why don't you just tell a little bit about your experience, Francesco? I did not ask you to do this before, but if you wouldn't mind telling us a little bit about what's going on with your company, it would be very cool.
I love improvising, Beth, no problems. Yeah, so we've been working on a technology based on membranes for separating gas molecules from one another. And one of the potential applications of this technology is capturing CO2 from different streams gas streams, in particular at point source in power generation plants or glass steel manufacturing. There's really a very long list. And we were at a very critical stage when we engaged with the Cleantech Open Accelerator. It really helped us building our business plan, building what's beyond the technology, because at that time we kind of had an understanding about, you know, performance in lab scale. Really, the technology we had figured out, you know, enough details to make a case for that. But we really needed to work on all the other aspects and really going through the Cleantech Open Accelerator with the team and the amazing mentors that they matched us with. It was an incredible adventure, and definitely being part of the carbon sequestration prize and winning that for the first time that was available. It was a great achievement, and I tell that to everyone I meet that I'm very proud of that. So.
Well, and then there's something else that's really amazing about Francesco, which he's very modest about, but within moments of completing the 2021 accelerator, he got a big investment right away. So that was very cool. So congratulations to you on your great progress, Francesco.
Thanks a lot. And all this really contributed to to position the company in the best possible way. So I'm grateful for all these initiatives that really help companies and individuals that are part of these companies to grow.
So we've invited Francesco to be a judge. We also invited one other person, Chao Yen, to be a judge. And Chao was our 2021 Cleantech Open National Grand Prize winner with his company, Princeton New Energy. Chao, do you want to just take one moment and tell us a little bit about your experience and what you're working on?
Sure. Thanks, Beth. Really appreciate it for your introduction. And happy to see everyone. I'm Chao, and as Beth introduced, I'm the CEO of the Princeton New Energy. And our technology actually using the plasma-based technology to recycle the lithium-ion batteries. So we have developed this technology which can reduce a lot of emissions and also can reduce the cost. Since currently the technology is very generate a lot of waste, like a hydro method or pyrolysis method. So that's why we have converted this technology from the Princeton University, and then right now we get several IPs and also the investment, and to look forward to build a production line in Dallas right now. And I think I would like to thank the Cleantech Open, and this is really a great platform that give us a lot of support to build our the business plan and for the pitch to the investors, and also give us a lot of introduction to the potential investors. And happy to see everyone here, and look forward to discuss more, and look forward for the future. The collaboration, anything. Thank you, everyone. Thank you very much.
Thank you very much, Francesco and Chao. And Tali, back over to you. It looks like our presenter may have just showed up.
Okay, Phoebe Fallon, are you on?
Hi.
Hi.
On my partner, if that's all right. I think his Zoom is malfunctioning, so he'll be joining in just a second.
Okay, we are going to need to get started pretty quick with your presentation.
Okay, for sure. Yes, I can share my screen if that is helpful.
Yes.
To get it started. Okay, great. Sorry, just 1 second.
So judges, we are going to be going back up to presentation number 20, Phoebe Fallon, monetizing a latent energy source, plastic waste. So Phoebe, just for your reference, you'll have 5 minutes to present, and at the end of that, we will move straight into deliberation.
Okay, great, thank you. Sorry. Okay, is everybody able to see? Just a second.
Yes.
Okay, great.
And it looks like your partner was joining, but I don't see them now. Oh, there you are. Okay, great.
Yeah, so hey everybody, my name's Alamede, and with me is Shubi Fallon, and we're students. And so our idea is called monetizing a energy source, plastic waste. And we're very excited to be sharing with you today.
Yeah. So just to go through our presentation, we're going to start with our business plan, move to our technology, go through economic feasibility and market assessment, and then we'll be defining success for our company as well as potential implications in the short and long term.
Yeah, so when it comes to the business plan, our goal is that by using microwave initiated catalytic deconstruction, we'll be able to capitalize on waste plastics as a source of hydrogen gas. And we believe that this should be able to drive the national transition to renewables. And the reason why this is that as it stands, the process requires lab-grade technology, the process of microwave initiated catalytic deconstruction. And that's because the technology is so new. And this has had the effect of preventing technology's general adaptation. And yet the technology is powerful in that it allows you to produce hydrogen and it allows you to produce multi-walled carbon nanotubes, which have applications in a number of industries. And so we're planning to address the problem, commercialize the problem, and bring the solution to scale. And we want to make sure that this is an accessible and affordable option for producers nationwide. And throughout this presentation, we hope to show you how we envision this happening.
Okay, so the technology uses microwave catalytic destruction to create hydrogen gas and carbon nanotubes from waste plastics. And it is able to do so with the shockingly cheap catalyst, which is iron oxide, and we'll get into the prices a little bit later. But basically within 90 seconds, by using this catalyst and directing microwaves onto the waste plastic, we are able to get 92% of the hydrogen present in plastic waste, which is made primarily of carbon and hydrogen, as well as 66 grams of carbon nanotube per gram of waste plastic.
Yeah, and when it comes to thinking about the economic feasibility of this, we actually think that it's pretty feasible, although normally operating in the energy sector requires a lot of high upfront investments in capital. And this is because we're planning to have a decentralized partnerships-based production model, which would be financed primarily by the sale of a byproduct of the process of creating hydrogen gas, which is referred to as carbon nanotubes. And we think, so we have reasons to believe based off market studies and based off of the price in the market that we can sell carbon nanotubes for about 40 a gram. And given that the process creates 0.66 grams of carbon nanotubes for every gram of plastic waste that is used, and given the fact that plastic is relatively accessible and that we can expect in the short run to be either paid for it or to have it for free, then we predict that we'd be able to finance our business model, which would involve the production of hydrogen via paying partners, whether they be in universities or research labs, to help us with this process.
So as we said, we did some market assessment and we'll be able to minimize our costs and also have multiple sources of revenue. So the plastic market is worth quite a lot of money, 48.13 billion in 2028. And as well, plastic waste is generally very widely available and cheap. We have a giant surplus of plastic waste in 2020, despite there being a pandemic. We created 367 million tons. And so there's a lot of it and it is not highly in demand. Most of it winds up in landfills. As for carbon nanotubes, many sectors, including civil engineering and chemistry applications, use carbon nanotubes, which is valued at 15.3 billion in 2017 and is also projected to grow. And finally, hydrogen is viewed as one of the energy carriers of the future, particularly clean hydrogen. And so right now, all forms of hydrogen today are worth 130 billion and expected to reach 201 billion by 2025. And for green hydrogen, it's growing even quicker. And we fit somewhere in between green hydrogen and other like more common forms of hydrogen, which we might get into in a little bit. And as well, ammonium producers, which use hydrogen in fertilizing companies, represent half of the current green market, which is about $450 million.
Great. Thank you for your presentation. That is the end of your 5 minutes. All right.
Thank you.
So we are officially done with presentations. So I'm going to, again, open the breakout rooms for the judges. You will be pulled into it automatically, judges. And I will hand the presentation over to Beth for a Clean Tech Open overview.
Thank you, Tally, and thank you all again for the presentations. And what I'm going to do, which is going to be super fun, I think, is to show you a little presentation about Clean Tech Open. So we actually had this, we have a great opportunity here to share with you what Clean Tech Open is about. And so I want to make sure that all of you get a chance to apply to Clean Tech Open, and you should be aware that Clean Tech Open is a national program. We're run in the Northeast by NECEC, which stands for the Northeast Clean Energy Council. NECEC is an organization that essentially lays the green carpet for startups and other organizations working in clean energy and related fields. This is all about working collaboratively between policy, regulatory work, and market development, along with innovation. So there are a lot of possibilities here to help you build your business, not just through the Clean Tech Open, but with connections from NECEC. So Clean Tech Open is a nonprofit. We do not take equity in any of the startups. The program is heavily subsidized by our sponsors. And I want to just run through a few examples of who our sponsors are to give you a sense of the kinds of people that you would have access to. So in Massachusetts and New York, we work closely with the Massachusetts Clean Energy Center and with NYSERDA. They are our premier sponsors. And if you are based in either Massachusetts or New York, there are many benefits to working with those organizations. If you have solutions that fit for Massachusetts or New York, there are also other opportunities, but they are working to help expand the entire ecosystem. We also have, as I mentioned earlier, 2 specialty prizes. They are sponsored by a small foundation called the Sire Foundation, and I'll get into the details of those prizes at the end. We also work with the Canadian Consulate in New York. They are helping us to make connections with Canada in different ways. Foley Hoag is a law firm based in the Boston area with offices elsewhere. The New Jersey Economic Development Authority and CSIT are working to enable efforts in New Jersey. And Sunstein is a specialty law firm in this area of IP. You'll see under regional bronze, AGC is Asahi Glass Company. So for people working in specialty materials, that is a company you want to be connected with. Citi is, of course, the bank, and we are working with the Citi Impact Fund. Chubb is an insurance company, and they offer assistance for testing, stress testing, essentially many of the solutions that come through. And we have a whole session on how to work with insurance and what kind of insurance you might need. Constellation is an energy tech company, and Schneider is similarly working in energy tech of sorts. They do work in the data center and with heating and cooling as well. Novartis is a pharma company, and Xylem is a water tech company. So there are a lot of opportunities to connect with these various organizations. You'll see under contributors, we work with Brandeis University, Energy, which opens up opportunities for folks in Europe. Mintz is a law firm with offices in Boston and elsewhere, general law firm, and Saint-Gobain is an advanced materials company. And you can see at the bottom, NECEC and Greentown Labs. We are based at Greentown Labs in Somerville, Massachusetts. In addition, we have over $300,000 worth of goods and services that are available to our startups that go through the program. And these are just, these are their logos, but a lot of opportunities which we get into once you get into the program, but things ranging from project help to software packages to space to do your work to specialty services and little variety here. So let me tell you what it is that we do. And this is where I think, as I heard all of the stories today, I believe that you all could benefit from Cleantech Open. So what we provide is a program that runs from the end of May through the end of September, with the core programming happening June, July, and August. So we have an online curriculum with many events that we're running completely virtually, and lots of business clinics with private coaching. Mentorship is probably the best part, which is why we put that in green. Mentorship is really an incredible piece of the program. We offer, we are able to match in this region, we're able to match as many as four mentors who are experienced professionals in this space to each team, and they work with you as an advisory board to help you through the curriculum, and in some cases they will continue to work with you even afterwards. Access to capital refers to how we can we set up relationships and introductions for you with various types of investors, including corporate strategics. So there could be some opportunities there with potential customers. At the end of the program, we also offer, we have a prize competition. And I mentioned this earlier, we'll have showcasing and opportunities to win cash prizes. Both Osmosis and Princeton New Energy told a little bit about their prizes. You're going to hear in a few minutes from a few of our illustrious alumni as well. You see a few different action scenes of our startups here. So at the bottom, you see the 2018 winners, which is Radical Plastics winning their grand prize at the Global Forum. So here's the schedule. Our early bird application deadline is February 28th. So if you get started now, you can meet the deadline and get your application in. We'd be happy to have you apply. We will invite you to our various events that we're holding between now and the end of the application period. We will hold a variety of events, and I can put the link in the chat again. Our final application deadline for this year is April 17th. We select the cohort, match mentors in May, and then we have our 3-day National Academy, which will be virtual at the beginning of June. It'll start at the end of the first day. Don't worry, you don't have to sit still for 3 days in a row. We mix it up a little bit. It's not a full 3 days. And then the core part of the programming is June through August. We'll run several business clinics, lots of webinars with additional content. And one of the key features of what we do is this greenhouse gas emissions reduction potential exercise that we started in 2021, where we are enabling our startups to do their own calculations and be ready for those conversations with whoever is interested, and especially with investors. We will help prepare you for the regional finals, which is why we have our mock judging in September. Our regional finals, will be 2 days. The second day is a public celebration where the finalists will present in a public forum. We expect that event to be in the Boston area. So everything is virtual until the regional finals. And then we do plan to hold the global forum in person as well, and that will be in California. So what does it cost? It is not free, but it is heavily subsidized. As I mentioned before, we do not take any equity. There's a $30 application fee if you get your application in before February 28th. And then after that, it's $75. The fee for students is $975 for the entire team. It is heavily subsidized, as I said before. So the real cost is $6,000 per team, and we are giving you a deal. If you are in any of these locations, New Jersey, Maine, Philadelphia, and Rhode Island, you may be eligible for reimbursement. There are various opportunities from those states to encourage your participation. So, and I mentioned the prizes. We are offering six separate prizes this year, 4 general prizes and 2 specialty prizes. The specialty ones are in carbon sequestration, and then the other one is ag, food, and land use. So what do you have to do? So we actually have multiple modules. We have, I believe, 10 modules of information that we share with you, and you go through with your mentor or your mentors. These are the deliverables. So almost every week you will have a new deliverable. Even if you have an MBA or you're working toward, you've created a startup before, or you think you're pretty far down the path, this exercise is very helpful. We systematically go through this process. So even if you have a financial model, we will help you refine it based on all of the information that you work on with us. You work on this GHG ERP, stands for greenhouse gas emissions reduction potential. And at the end, you have all these different deliverables that you can use to help you get started and run your business. There are other things that fit in between here. So topics include working with attorneys, working with insurance, building your team, and there are probably some other categories that are not listed here as well. So how well are we doing? We started in 2005, and in 2020 we did this analysis of our alumni in the Northeast, and you can see that our region goes from Canada, Eastern Canada. We have Maine, south through Pennsylvania. And at the time we had 414 alumni. We learned that 68% were still in business, and they were earning $279 million in revenue and had raised $653 million. We believe the numbers are significantly higher. The numbers have grown significantly over the last few years, but this is where we were at the time, and we are going to continue to grow. We do also know that our footprint in terms of number of jobs created is over 3,300. And diversity, we are doing pretty well in diversity, and we are continuing to address diversity, equity, and inclusion across the spectrum. So I mentioned greenhouse gas reduction. Because we're a clean tech accelerator, we are very focused on how well are our startups doing. Last year, we had our first opportunity to have our startups tell us how much they think they will reduce when they are at scale. And they came up with 101 million metric tons of CO2 equivalent per year when they're at scale. This represents 44 startups that completed the program in 2021. So 22 million cars off the road is not too shabby. We are very proud of this, although it is a projection, it is not actual. So I do want to make sure that that is clear. So going on, what are we going to continue and really highlight in 2022? We have a focus on diversity, equity, and inclusion, and some content as to how to build those into your startup from the beginning. We have the Ag, Food, and Land Use Prize. We have our second annual Carbon Sequestration Prize, and overall $60,000 in cash prizes and over $300,000 in various goods and services. So what do you need to do to apply? You all are there already. I would say that you all should apply. You all have explained that you understand that there's a market, there's a need, you have a solution, or at least an idea of what you're going to do to solve that market need, and we need to see who's your team, and do the judges really believe that your team can pull this off? So it is my distinct pleasure to introduce you to three of our illustrious alumni. You already heard from two, but I'm going to introduce you to three others. And I'll tell you a little bit about them, and then I'll turn off my screen so each of them can have a few words, and each of them will speak for a couple of minutes. So Nick Davey is the CEO and co-founder of Andluca. He participated in the 2020 accelerator and was a Northeast winner with his company. Derek Stein was a finalist in 2018 with his company Textile Materials. He's a professor at Brown as well. And Elise Stroback is CEO and co-founder of AeroShield, and she was the national grand prize winner for the entire Clean Tech Open in 2019. And we're really proud to have all of them here to tell you a little bit about their experiences and what they're working on. So I'm going to stop sharing and turn it over to Nick. Are you ready, Nick?
Thanks, Beth. Definitely, yeah, great job going over the program. Happy to be a Clean Tech Open alum, and certainly it's been an exciting ride since 2020. The 2020 cohort was in the heart of COVID, so it was just, we had to figure out how to do the program virtually, and I think it was particularly helpful to have the community of entrepreneurs and the programming to still be able to harness a lot of the energy and support for clean tech virtually. So you did a great job there. For us specifically, Andluca Technologies is a company that I founded at Princeton with a professor there I was working with during my PhD. I've developed advanced materials to use in smart windows and smart glass. So we're focused on the built environment and reducing carbon in the built environment. During Clean Tech Open, we refined every aspect of our business. Really, we grew the team. So through the networking with Clean Tech Open, found a key additional team member. I actually used the program to vet another team member who I had do the program with me, who wanted to join the company and was at NREL at the time as an employee. And then we had great advisors. Of course, the advice you'll get is spend as much time with your advisors as they'll have of you, and make the most of those relationships and have them introduce you to others in their network. One of our advisors actually became part of our IP council and helped us with our IP strategy. That was pretty significant. Another one helped us with our financial modeling. And another one helped us with our customer discovery and beachhead market definition, which really meant understanding the customer and unit economics and a lot of these factors so that we could speak credibly to investors. And then that was through the Clean Tech Open as well, we met a number of investors and used the deliverables to prepare us for investment. Ended up having a pretty good success with investment following the program. We raised $550K right after pretty January, so pretty close after the program. Then won a phase 2 NSF award of $1 million, which is predicated on you being financially solvent to qualify for that award. So it's a step-by-step process, but definitely really recommend the program and recommend the building community through the program, both in terms of your team, your advisors, investors, and the deliverables are something that you have to do anyways. So that the way to think about the program is really one step, multi-step process being guided through what you need to do to be successful. it's not something that's added on to your list. So anyways, thanks, Beth. And hope you guys get some great applicants this year.
Thank you very much, Nick. And I'll turn it right over to great to hear your voice and hear your story and to see you as well. Derek, you're on.
Sure, thanks, Beth. So hi, everybody. My name's Derek. I founded a company called Textile Materials in 2018, and it's also for the built environment. So it's a material for building envelopes that improves efficiency, durability, and air quality. I was inspired to do this because if you look at the energy pie, buildings represent a very big slice. It's like 40% of primary energy traces back to buildings. And it doesn't have the same draw as some other technologies do, and I thought people should be working on this. So as far as the Clean Tech Open experience goes, so what Nick just said and what you've been hearing from Beth is absolutely true. It's a great experience. Let me just give a slightly different perspective and speak to maybe a different kind of person here. So it is absolutely true that, as Beth said, if you have a pretty good financial model, you'll be able to improve it. But you might be a different kind of person, a person who doesn't even know what a financial model is. If you're at a university like I was, there are a lot of these words that are floating around that are completely mysterious to you. So, like, what is your executive summary, right? And that doesn't just mean a paragraph, it's something else. So all of this was kind of mind-boggling, and it can seem sort of overwhelming. The Clean Tech Open is the best way that I know of anywhere to get introduced to this so that it becomes demystified. So that at the end of a process that lasts a few months, you come out understanding what people are saying, you're able to start slinging the lingo yourself, and you've been guided by really, really competent people through the various things that you're going to need to show to raise money, to get partners, to attract people to join you, and so on and so forth. So the financial model, your pitch deck, your business model canvas, all of these things that may seem like, what's this all about? It's really digestible. The Clean Tech Open is the best program that I know of to take you through this. And then furthermore, the kinds of people you'll be linked up with are top-notch. So especially in the Northeast. And I'm not just saying that, the people that you'll meet who have expertise in technical things. So you probably have some comfort there, many of you who had a technical idea. But then on the business side of things, how do you make a deal with a partner who's going to manufacture things? Well, this is something that people have spent careers doing, and you'll meet those people. So whatever your need is, there are people in this network that can help you solve what problem that you have. And so I had a great experience. I love what I do. I get more and more excited about it every day. And I still have a very, very warm place in my heart for the Clean Tech Open that sort of launched me on this great trajectory. Okay, that's all I have to say.
Thank you very much, Derek. Always great to see you and to hear your wise comments. I'm going to turn it over to Elise Strobeck.
Yeah, thanks, Beth. So excited to be here today. My name is Elise Strobeck, and I'm the CEO, inventor, and co-founder of AeroShield Materials. And we're working to manufacture a nanoporous form of glass that goes inside of windows and actually helps tackle more of this problem around that we've heard from all the speakers today on kind of the built environment. In particular, the thermal losses through windows cost the US $40 billion in energy every year. And to see that energy and that money go right out the window is a pretty alarming number. But then when we think about, well, how do you solve problems like that? It starts to become a really complicated problem. When you think about materials that are insulating and durable and affordable and can withstand the environment that we put our buildings through. And so it was actually during my PhD at MIT that I was working with this really interesting silica aerogel, or a nanoporous form of glass. And it was, as we got better at understanding this material and actually had a breakthrough where we had something for the first time that was super insulating, actually 2 times as insulating as air, but could be clear and could go into a window. That was really the moment at which, kind of my research scientist hat changed a little bit into this entrepreneur hat to say, well, this seems like it could solve a really big problem that is really tough to address. But I also knew that at the time I couldn't even spell entrepreneur. So I didn't know what it meant to take a technology like that out of the lab and drive impact with it. And that's really where the CleanTech Open comes into the AeroShield story for us, because even before we founded the company in late 2019, one of the first things that we did was signed up for the CleanTech Open Accelerator. And I think as you've heard throughout these stories, it gave us exposure to a lot of different things. The hard skills of, making a financial model and having somebody to talk through it with, somebody who wasn't a researcher who could understand what those things meant. But it was also an opportunity for me to practice talking to people in this ecosystem. I'd been used to working in the basement with materials on machines. And so the idea of going into a room of investors who would, ask questions that I didn't know how to anticipate, that was pretty scary for me in the beginning. But the mentors and the programming and the workshops and the kind of the guidance that the CleanTech Open gives you and kind of builds to this idea of you put together this packet of information. And it's really about exploring it and asking the tough questions and getting help and getting visibility on it and getting all these amazing opinions. And then you find that as you get advice from this amazing network and through these resources, those are also the people that you go back to that, even it's 2022 and we were part of the cohort in 2019. And even now we still are continuing to explore these connections that we made during the CleanTech Open. So really excited to see programs like we have here today, start to identify and help even more of these researchers come out of the lab. And I would have to say, I agree that CleanTech Open could be an excellent part of that journey for everybody here today.
Thank you very much, Elise. And if I can quote you, when you finished the program, I remember you saying to me, CleanTech Open saved me X amount of years. Do you remember that?
I do. I think it was 2.5 years, I think, which, yeah.
Yes. And that was incredible when you said that. And I've been quoting that since that, if you want to save some time, really dig in and apply to CleanTech Open. Elise and her team saved 2.5 years. That's amazing. So thank you very much, Elise. Great to hear from all of you. I am going to now say we have a little bit of time. So maybe we can do 15 minutes or 20 minutes with maybe 15 minutes would be good of breakout rooms. So what I'm going to suggest is that all of you go to your Zoom. This is the fun part. And on the bottom of the Zoom page, you will see a button that says breakout rooms. And when you click on that, it will show you different categories. You can move around. You can go to the bottom there, you will see building technologies, geothermal, fossil energy and carbon management, nuclear, solar, water power, agriculture, and land use. So pick one, move around, see who joins you. You can click on the button that says join and that'll pull you right into those meetings. So I welcome you to meet others and happy networking, and we will pull you back when it's time to announce who the winners are after the deliberation. And if anyone wants to stick around and ask any questions, I can stay here for a few minutes. So, and if you are having trouble finding one of those rooms and getting in, let me know. Is there anyone still here who wants to have a chat? So you don't want to go too far away because we will be announcing the winners soon. So if you're just joining now, or if you are on mute and not showing your face, you are all welcome to. I'm going to. Thank you very much. So what we're going to do is something kind of different. We're going to ask all of you to pick an audience choice. So which startup did you like the best? So what we're going to do is have you go to Slido. Just go on your phone or your computer. You can just go straight to a website that is sli.do. Enter the code with all caps, CTODOE, that's Clean Tech Open Department of Energy. So CTODOE in all caps, and you will see the list of teams that participated. Pick one. That is your choice today. Pick which one you like the best, and we will have a People's Choice Award. So if you would like, you also can use this QR code. Just put your camera over that QR code and go right to that particular Slido. If anyone has any questions, speak up. I am here. I will stop sharing for a moment so we can see each other, but it is sli.do. Everybody able to access that? Any questions? Okay, I think what we'll do is we will see if anyone has chosen the Slido, and I'm going to see if I may be able to see. No, I'm actually not able to see what the answers are. Has everybody voted? Okay, it looks like the votes are. I can see that there are a few votes that are getting tallied. Great, so continue to vote. And what I will do next is I will go through the next couple of slides, and then we'll bring in the judges, and they will make their big announcement about who wins. So let me share my screen again. And when Tally returns, we will hear who won the People's Choice Award. So what I'd like to do is, let's see if this is able to show. Okay, so we talked about this. I do want to make sure that everyone has access. Clean Tech Open is recruiting now for the 2022 accelerator cohort. And we do encourage you to take a look at our media kit. You'll see upcoming events, lots of information. There are brochures, there are introductions to different topics that we address. And here it is, it's bit.ly/CTOMK, which is Clean Tech Open Media Kit 2022. So I also welcome all of you to follow us on Twitter, Clean Tech Open NE, Clean Tech Open, which is the national organization, and NECEC, which is the Northeast Clean Energy Council. So check out our media kit. I hope to see you at some of our other events. And also wanted to encourage you all to apply now. So the final deadline is April 17th to apply to the 2022 Clean Tech Open cohort. So I hope that you all will do that. And I'm going to stop sharing and see if the judges are almost ready to come back. We'll see. It is now 6:31 so Eastern time. So I do want to make sure that we don't keep you too late in having the judges tell us who the winners are. And as you know, there will be one Northeast winner and as up to 6 category nominees for the bonus prizes. And all of those teams that are chosen will have the opportunity to compete in the national prizes at the national event at Carnegie Mellon during their Energy Week. So I'll open it up if anybody has any questions while we're waiting for the judges to conclude and tell us the answers. Anyone have any questions, comments? Oh, the code. Oh, sorry, the code. If for the thing, it's CTO. No, I think it's DOE. It's either CTO, DOE, or D. Hold on one second. Try that. Wait a minute. Let me get the code for whoever is asking. I can't remember if it's CTO, DOE, or DOE, CTO. One second. It's CTO, DOE for whoever was asking about the code, all caps. All righty. So I will tell Tally that we are ready. Okay, everybody's so quiet. You weren't quiet when you were presenting. All right, I'm going to stop that. For this answer. So the answer is that CleanTech Open looks for companies that are in this broad category of early stage. And what we mean by that is companies that can benefit from our curriculum. Typically, the companies that come to us are pre-customer, and they typically have anywhere from zero funding all the way up to 1.5 million in venture or angel funding, or up to as much as $10 million in grant funding. So the range is pretty broad. We typically have, I would say that all of you are at the right stage. From what I saw, we can help you to advance your companies and give you that extra boost. Companies that go through this, or teams that go through this, really helps to build your, to stress test your business idea, and to build your networks, and to help you connect with people who are going to help you make a difference and grow your companies. So, and in many cases, it's of course a safe space to work. So in many cases, folks will pivot and make some changes as they go through the program, or perhaps shortly after the program. So I hope that answers your question. And it looks like we have the judges back. So Tally, do you want to lead this off?
Yes, so I'm actually going to present all of it since I have the information right in front of me. So we wanted to present our winner. We are really excited. I hope that they are still on the line, but if not, that's okay. So congratulations to the Northeast winner of the 2022 DOE Energy Tech Up event. It is the plug and play nuclear energy generator presented by Edward Garcia. And I saw that you're on the line. So congratulations.
Wow, thank you. Thank you. That's amazing. Wow. Thank you. Thank you very much.
Congratulations. I also have our bonus prize winners. And Edward, you are also our bonus prize for the nuclear energy sector. And our bonus prize for the Office of Fossil Energy and Carbon Management is the electricity production with negative emissions, presented by James, I believe. And you had a partner, but I don't have the name at the top of my head. And we have our, and Cameron, would you like to say something?
No, thank you so much. Awesome.
Yes.
Thanks. James had to drop, but appreciate it, and some great presentations today. It was cool learning about what everyone's working on. So thanks, and thanks for organizing. It's really cool.
Awesome. Of course. Our winner for the Geothermal Technologies Office is the Mesophase steam condensers, presented by Michael. I believe you might still be on the line.
Yeah, thank you. We're psyched.
Awesome.
Good to meet you all.
And great. I'm really excited about it. The very last bonus prize that we have to present is the Solar Energy Technologies Office, and it is the Roll Up, Roll On Solar Panel Team, presented by Nicole Eaton.
Thank you so much. I really appreciate it.
Congratulations to everyone that participated, and thank you all for sticking with us. We are the first of the regional conveners, so we learned something, and I hope that you all had a great afternoon. Thank you so much to our judges for staying on the line and working through the deliberation with me. And congratulations again to all of our teams, and we wish you good luck if you do start your startup, and we wish you good luck through school.